All right, I'm back. Okay, let's see. Good times. Another same message redacted. What? You got rid of that message. You can do that? What is that emote? Enze Popo. This is Popo. Where's Enze? There's the Popo. Alright, how do I get rid of that window? We'll get started soon. It's a potato. I'm not going to do too much intro. Meant to send that to somebody else. Okay. Well, I'll try to emotionally recover from what you said. Not to me. Oh boy, we got a lot of work to do. This is a lot of work. This is a lot of work. Building an entire piece of hardware that's going to enable me to work, do all this work for my friends. He's the booger. I don't listen. I didn't expect to just start my stream and get called a booger. Okay, it has lasting effects. Your words matter. All right, not a lot has happened since yesterday. We're just going to continue on and do our thing. See if we can work all this stuff into all of this other stuff. I do have a particularly challenging device to make. How do the pot? Okay, look at this. So the when I clicked on the potato to see what it was doing, it was like, what is this potato? Oh yeah, that's commands are updated. We can close that. What is this potato? And so I click on it and the pop-up comes up, but the pop-up, the X box is barely even noticeable. It's up here in the cutoff piece of the window. I do a lot of windows, like a lot of separate windows for stuff, just so that I can keep on the up and up and what's going on, because I have to monitor 2 chats at once. It's not unchallenging to do, but for some reason, nobody's good with like the width. Good vibes today? Maybe. I'll be mad at CAD, not chat. So, but yeah, the width of the windows, I always narrow it down a lot, and a lot of these like designs don't take that into account. It's like, why are we hiring designers, web designers? Like, you guys are wondering what it is you should be doing with all of your time instead of just making the icons slightly differently. Maybe let's work on narrow window compatibility, so that our streamers who have fairly limited monitor space, I mean, it is limited. It seems like it's not, but it is fairly limited when you're doing a whole broadcast. I like this song. They can actually manage their stuff. Music is a little loud. Maybe we should turn it a little down. The non-YouTubers, Twitchers, are listening to Deckard. Deckard is a DJ out of Space Cowboys, which is a California, I think, music collective. But Deckard has these My Definition of Chill albums, so they're really good just to put on, like as background sound, you know. They are really good songs, but they're also ones that have kind of just like a good vibe to them. So I enjoy it very greatly, and so I play them as a lot of the intro music. I don't want to get blamed. Hey, Walrus, what's up? And Weaselbox. Listen, I don't want to get arrested. I'm not going to wear a banana costume. There's somebody in Pennsylvania who got arrested wearing a banana costume because they had it on during one of these car meets that are apparently what they do now. You see, we used to get our cars together and go to a random parking lot, and everybody would stand around and talk about cars. That's not good enough for these new meetups. These are like flash meetups that suddenly get together at an intersection, and they start basically just doing circular burnouts. They're just quote-unquote drifting the cars, but without an aim of actually getting around a turn faster. And what ends up happening is you get a giant crowd of people, and you get a car screeching to death in the middle of it, spinning around. People get injured, et cetera, et cetera, et cetera. The police try to rein it in, and it's all chaos in the city. And this kid, this 18-year-old, was wearing a banana costume, and ended up being from the suburbs. So all of those people who talk about how dangerous, oh, Philadelphia is so dangerous, you're gonna get shot, you're gonna get robbed. No, you're gonna get run over by a suburban kid in a banana costume is what you're gonna do if you go to Philadelphia. It's not that unsafe of a city. You just stick to the main places and don't deviate out to the more dangerous neighborhoods that are in the surround of Philadelphia. Yeah, I forgot about that drive emote. Windows update, restart to install. I feel like as soon as I capitulate and give in to the Windows update, there's just another Windows update waiting for me. It's like a perpetual cycle that's really just getting on my nerves. Why do you need to update so much? Stop it. No, we don't need to put on costumes. That would be your choice, not mine. God, this thing is huge. It is such a big chip. It's not really a chip, really. It's a development platform. Hey. All right, we're deep into it. We're deep into it. We've made our commitments. We are going to be building a circuit board for this tester. What's up, Sir Hiss? You're no fun today. That's not my fault. I'm task focused. I'm ready to go. I'm ready to design a circuit board. For what it's worth, it's going to be a bunch of faffing about today. We'll probably be able to do a good job replicating the board that's already there, and then branch into importing microcontroller platforms. I got to put pins on the TC4 and then get that into CAD, which I've got all the stuff that I need for it. It's going to be a lot of counting pins. Getting the chips in is like a big deal when you're designing a circuit board, and so we're deep into that. And I'm gonna make a lot of progress over the weekend. I'm gonna hopefully get up on time, get all my morning stuff done, get the dog walked, get her all satiated and everything, and sleeping, and then get to work in CAD, making my butt hurt on this stool by sitting in it for hours at a time. Oh, I forgot about this mix. This one is the Deckard, it's like Volume 7 Brazil, and it's got a lot of really good vibes going on this mix. How's everybody's Friday going? It's Friday vibes. We don't have to think too hard. I guess I do. I have to be entertaining, but everybody else gets their week wrapping down, and then you get to do the weekend chores, and then when you're done those, you get Sunday night anxiety, and then it's back to work. Burp. Glad it's Friday, yeah. It's been a weird week with the hurricane, kind of, the hump day hurricane. I got deadlines. Yeah, man. It sure as hell isn't linear, is it? It's like a burst economy of work. I tried to do my errands on Friday, and it was not a great idea. Everybody, it's like there aren't many people like in the shops and stores that I have to frequent for my my normal old Saturday where you are. Okay, Mr. Future Time Traveler, sheesh. Just because you're on that side of the plate-like Earth, the plate-shaped Earth, where there's a giant pole and it tees off, and then there's two little light sources on the ends of the T, and that spins around. That's what Earth looks like. And there's an ice wall all the way around. Anyway, yeah, all the shops were like empty. The roads were packed. I think I went out at just the time when everybody started to like take their morning like break or go get lunch or something. At least we know tomorrow is happening. Oh, that's true. Yeah, if Blue AU was instead just a ceaseless void, then we could be worried. Nobody's really planning on Saturday, but it's going to come in anyway. I don't know what to do about the power stuff on this. If we're making our own circuit board and we're making this thing more of a module, like this will be more of its own isolated module. Then what of this? Maybe I need just like a daughter board that sits up on top of this. Maybe I can plug into that, or I could do these 4 supports. Maybe I just do these 4 supports and I put something there. What size is that? I think that's this size. It is just outside of that size. God damn it. It needs to be stable or else I can't plug stuff into it. I mean, I guess I could move the standoffs in a little bit to this section. And then it'll... Wait, there's a chip in here. What the hell? What's that doing in here? What does it do? It's an unexpected location. Plot thickens. Is it a government tracking chip? Might be. See how it ran away? I still regret that we did all of that optics table work and we ended up proving that the Earth was definitively flat because our interference, we didn't know how to read interference patterns. And I think a diode laser is potentially not super suited for that application because we're relying on sort of the parallel nature of waveforms on a micro, like what is it? Micrometer scale, not micrometer. What comes below it's like pico. I don't know, but anyway, we're dealing with 2 light paths that are supposed to be in parallel with one another, and the waveforms are supposed to be on top of one another, and then we get an exaggerated interference pattern in the end. And when we twist that optics setup, one direction will become microscopically, like on a micrometer scale. We're talking about like sub-wavelength scale. It'll become longer than the other one, and the waveforms will be out of phase. And that creates an interference pattern. It's the phase of the waves canceling and amplifying each other. So we observed possibly an interference pattern, but I couldn't like spin the table. I need to make get one of the lithium-ion cells that I have over here, the RC car batteries, the big ones, and put that on the optics table if we're going to use that diode laser. And then get the 2 paths aligned properly, which I think is the challenge. I'm not totally sure about that. I'm not sure if that's the big challenge or if I just don't know what I'm looking at in the end. Alternatively, I have pre-made fiber optic cables for like networking, and they're pretty long cables. So if I can make 3D print the optics to get a diode laser into those fiber optics, what we get out on the other side is an enhanced beam path. So it's a much longer beam path, and it's much more sensitive to turning. I saw it done for like a science thing, and the science guy had like a cord that connected it, and he was able to spin it, but the cord was like all twisted up. We can get around that. We're better than that. We can just use battery. Just use battery. It's just the camera is the other question. Maybe I can use that wireless camera. And then I don't know what the optics are like for an interferometer. It's some kind of an imaging plate. If it's just like a camera that you put your laser on. I know the real ones are really expensive. If we look up an interferometer. God, fucking AI, go away. I guess optical interferometer is not a device. Interferometer is just what we're talking about making. So interferometer sensor. Sensor. Make one. Out of what? I don't even know what it is. I don't even know, like, you gotta know what you're making before you make it. This is a displacement interferometer. Huh. White light interferometer. We're talking big science. Like, these things are gonna be so expensive. It's gonna be, please call. Yeah, this is different. These are all displacement measuring. That's, I guess, what the keyword is. So I need to figure out what the thing is that I would need. Kidney isn't going to cut it. Oh, no. It's more expensive than that. What are we talking about sensing? I mean, it's basically like a webcam sensor. A webcam sensor is probably more sensitive than that. Hey, lawn dog. Okay, they spell laser wrong right in their title. Hold on one sec. All right. Wait for the doxing emails to come up. An optical mouse sensor. That's actually a possibility. That may be what we need. Mouse sensor interferometer. Wait for it to dox me. And where's the pop-up? Oh, I guess it remembered. Okay. Let's switch over to Pay Reddit, just because I can't stand this interface. So much better. All right. These are a great way to track motion. They're designed to track 2 axes and very precise. Challenge those expect. Sensor expects. This is the HOTAS DIY. So hands-on throttle and stick. It's the simulator setup kind of thing. It's been done. Check this out. So what are we doing? You've got an optical mouse layout down there? 36 images. All right, so we got plenty of images to figure out what's going on. I'm more interested in this now than I am in what we were talking about with lasers. With lasers. What the heck? Cougar's guts are hooked up, and one of the pots has been replaced by a Hall sensor test. Software running this test, Thrustmaster Target Analyzer. I tested both A1302, 1301. What the heck? Huh. What in the world are these people doing with their joysticks? They've got some insane stuff going on here. You could just have a potentiometer do it. Why all this? What's all this doing? Oh my goodness. There's some crazy shit going on there. I mean, the Hall effect censoring is done really well. I thought it was an optical mouse sensor, but I don't see one anywhere. I don't know if that's... Created one for MechWarrior Online. I think I've had on my to-do list. Zero order controls, super informative, helpful. Doesn't use the optical... Okay, all right, so that didn't even... Man. It's not even what we're talking about. Later date, when I was starting to explain to the difference between native mouse input and emulate, so I made the stick to actually... Mouse joystick hybrid. The thing is, like, a mouse is moving on a linear surface, whereas the joystick is moving in a semi-sphere, which is what this is doing. And the Hall effect sensors that Thrustmaster use are actually very good at this. Science Direct has an article? Yeah, you would need to translate the motion, and then it doesn't necessarily meet up to the same parameters, but I mean, I guess it's doable. Yeah, post a link. I want to take a look. Control demystified. I mean, it could all work fine, but I have to cut and paste this. Ugh, cookies are such a broken system. Optical sensors are used extensively for displacement measurement. A cost-effective optical displacement sensor will be invaluable in applications where a high resolution is not required. I have a drone mouse sensor on a board. That's essentially, they put a miniature camera lens in front of the mouse sensor, and then the mouse sensor looks at the ground at a distance to get displacement as if it were a computer mouse. Mm. Yeah, that's reading research papers. I've read a lot of research papers in my day, and they pepper the language with ultra-specific terminology. And you often have to go through and translate that into normal language in order to figure out what the hell the paper is getting at. Optical mouse has been investigated to determine its suitability for two-dimensional displacement measurement. While the mouse worked only on objects with opaque surfaces, experiments conducted with a commercial unit with 0.0635 millimeter resolution, is that millimeter? Should that be nanometer? Show that highly linear and low error measurements could be attained. On the flip side, wow, they used on the flip side in a research paper, the unit could only operate if placed at a distance no greater than 1.25 millimeters from the object's surface. Overall, the optical mouse has been found to be a valuable two-dimensional displacement sensor. So what they're talking about is the position from the sensor, like the distance to the sensor, I think. Is maybe, I don't know, I think that's what they're talking about. A wide variety of displacement sensors have been developed based on the principles for capacitive, inductive, magnetic, ultrasonic, and optical sensing. For displacement sensors based on the optical effect alone, designs have been reported employing the principles of triangulation, interferometry, Moire diffraction, Moire diffraction, time of flight, and speckle. So yeah, this is all distance measurement stuff. There are different principles of distance measurement, and they're trying to use the interferometry capabilities of a mouse. Your drawback to the majority of optical displacement measuring tools lies within the relative cost. This arises primarily from the expensive. So this is, I mean, it is doing interferometry, but it's doing like a specific, I don't know about us shining a laser at it. That might be totally viable though. Maybe I just need to get a cheap computer mouse and we just get the sensor out of it, or use one of the ones that I already have. And if that is doing a degree of interferometry, we can insinuate motion on X and Y to be a changing pattern of speckles that is typical of a mouse moving on a surface, and perhaps that also translates to the rotation of an interfering laser, of interfering laser beams. Maybe? I don't know. That would be very interesting if we could get the mouse moving on screen and go, oh, there, it's movement. Oh, here we go. Light emitting diode illuminates the surface at an angle. A lens is used to image the surface of the mouse pad onto a CMOS sensor located in the camera chip. The off-axis illumination by the LED helps to put the tiny textures on the surface in sharp contrast. The CMOS sensor typically comprises of 18 by 18 pixels. The mouse works by comparing the images of the surface that are refreshed. So yeah, that is exactly what we need. The XY capability is not necessarily something we need, but the interferometry measurement of a computer mouse would be akin to our laser interference pattern. So yeah, okay, now I know. Now we know how we can get a good microscopic image of the interference pattern of the laser. Someone made a YouTube video about how it works a few years ago. We Googled it when we did our optical bench experiments, and we got to see a lot of setups. But I have a challenge of having a rectangular table, and I don't have a helium neon laser that emits on both sides. Because that's the best, is if you get that helium neon emitting on both sides, those two beams are in lockstep with one another. Oh, did 8-Bit Guy do that? Yeah, 8-Bit Guy's interesting. His content's okay. I haven't watched much of it lately. All right. Well, that's encouraging. When we bust out all the optical stuff in the far-flung future, we can check that out. I gotta look at the HOTAS DIY subreddit more. Yeah, he's still putting out content as far as I'm concerned. It was an 8-Bit Guy? Oh, okay. Real images of what the mouse sees, but it's 18, well, the typical one is 18 by 18. I guess that's not to say about resolution. I don't know if this one's infrared or laser. I don't think this one is laser. I think maybe the one at my desk is. Branch education, I see. I don't know that channel at all. At all. Yeah, you could, I wonder if you could make, how far can you get into those drivers? You can make a little 18 by 18 display. That's the size of the smallest Twitch, the small Twitch emotes is 18 by 18, I believe. Or no, is it 36 by 36? Might be 36 by 36. It's very difficult to operate within 36 by 36 pixels. There's not a lot of visual data for a human being. You really need to work with pixels, and then people insist on working with MS Paint for pixels, but MS Paint doesn't soften edges for you. You need something that will soften the edges. You need those gradient colors of pixels, because you can't just put a line across something. It'll look awkward. It looks too sharp. It helps to design in larger pixels and then immediately scale it down. I kind of think about it at its smallest form, but I design it in much larger terms. And what I really should be doing is designing my emotes in vectors. I haven't done that. I haven't cracked that egg yet. Is completely designing them in vectors and then scaling them down from there. Because if you do it in vectors, you can make a poster, you can make a billboard with your graphics without them looking shitty. I can make a T-shirt. I can put it on a mug. Put your name on a toilet. I can do it all. I'm like background tired today, right? Like I'm not like that tired. Oh my god, my eyes have like my eyes are just bags today. That's bad. I'm not like, I don't feel super duper tired, but I'm just like, I don't know. It's like background. It's like background noise. I am perfect. Well, you know what it is? It's caffeine. I have caffeine propping me up right now. That's what it is. That's okay. We got work to do. We got to get to work. We got to do work. I'm going to display what kind of, this is going to be a wonderful display of work getting done. People are going to tune in and go, oh my God, look at this man child, this bearded man baby on the internet doing work. Look at all this work that's getting done. That's what today's all about. It's not about relaxing on a Friday, being tired. It's about working. Work. Be useful in society. Get things done. Put your name on a toilet. That's just something Jack said in one of the Red Letter Media unidentified videotapes videos. That was Don something or other. So I can't put Dave's synthesizer back together because I have to keep this one distinct. All its parts need to be distinct. So Dave's synth is probably going to get like a special place where all of its parts go for later reassembly. And then at some point, probably maybe Tuesday or sometime next week, we'll take a look at the specific parts that we need to replace for this one to function again. I'm probably going to have to order more chips, considering we've gone through so many with Dave's synthesizer. I'm not sure if I took all the parts off. I didn't do it all in one swing. I did it sequentially, and I think that might have hurt the synthesizer in some way. But there's not much else to the functionality. All I'm doing now is reverse engineering it. The problem being is as soon as I have these things fixed, I don't have a way to test them. I would like, if the modular synthesizer tester fully worked, I would be able to repair this thing, plug it in, test it, and say, yes, it works. Okay, put it in a bin, send it back. And then if the person who I'm repairing it for says, actually, it doesn't work, I go, no, you're wrong, try again. Because I would know that I've been sending it all the proper signals. And then they accidentally plug it in wrong again, and it blows up. Evil module. I should have just told Dave to kick rocks when he told me he wanted me to help repair his. Hey, I plugged it in wrong. I didn't mean to. You can only plug it in one way. I'd be like, ha ha ha, that sucks. Bye. Like, just not work on it. Use your evil powers for good work. Yes. Well, as much as I want to listen to this mix, I guess I'm gonna fade it out now, and we're just gonna get to it. We're gonna get to it from a short intro of only 32 minutes. It's a good mix. I really like it. Good chill vibe. Hi. Oh, I didn't even activate start soon. Well, bother, why isn't start soon there? Bother, what does start soon mean? Why does it start soon? Hi. My name is Bother, and I'm an addict. This stupid fucking synthesizer stuff is still plaguing us, and I didn't mean to curse all but 5 seconds into a video, but whatever. I guess the intro counts as part of the video, so it's been over the curse monitoring timer. I have two 303s sitting here. The 303, the M303 in particular, suffers from a lack of user instructions. The plug on the back of the M303 is an insulation displacement cable. So multiple lines on the cable. Anybody who's over a certain age recognizes wires like this from the inside of computers, and this is an old school way to get lots of pins into a location. It's a way we used to plug our hard drives in. These things typically are, well, they come in various different flavors. The more DIY natured one is just a bunch of 0.1 inch spaced headers in a grid that are just dual row. You can also have ones with a keyway. That's a little nubbin on it, and you plug it in, and the keyway makes sure that you can't plug it in backwards. Or you could be like 3M, and you could make your own type of IDC cable that for some reason exists, although it is an affront to all morality and holiness in the eyes of God. This thing is an abomination. It is a psychotic machination of a just a mind gone completely sour. It is an affront to morality. This should not exist. Here be dragons. We are seeing things that are completely against all reason. This is an IDC cable, what has just little cavities in the side so that you can plug it in anywhere on your flat cable for the purposes of question mark. Why does this exist? Why is this here in a good society? Why do bad things happen to good people? It's this cable. That's why. This is ridiculous. This is supposed to be plugged in, offset by 2 pins and facing this direction so that your stripe ends up being the lower pins of this header, which are stripe, which in modular synthesizers represents negative 12 volts. Negative 12 volts is stripe. Stripe is pin 1. Pin 1 and 2 are negative 12. 3, 4, 5, 6, 7, and 8 are all ground. And then you got plus 12, and then you got 5 volts. And then Acid Labs decided to add a couple extra pins for control signals that you can internally route in your synthesizer. And what this does is this makes this product uniquely suited to blowing up people's hard-earned money. It is absolutely psychotic. If you get a bunch of Acid Labs stuff, you can daisy chain the larger header pins from module to module to module to module, and then you can click like a switch in order to send a control signal internally and take a control signal from internals on another module. It saves you having to plug in an external plug, which is also a complete affront to the modular synthesizer, because modular synthesizers want you to run a plug externally to wherever you're getting your signal from or to. So why would you have internal signaling going on? I don't want to plug in a bunch of cables in order to give everybody the same BPM. Well, guess what? You bought a modular synthesizer, you're going to have to do that. You're not special. So anyway, they decided to do this and not label it in any way, shape, or form. There's not even like a little recommendation. They have a silkscreen on this layer of the board, and they even have text down here in the copper. Put something in the copper. Do something. Anything. Just please get it so that people stop blowing these things up, because this synthesizer is painstakingly built to mimic the 303, which is a legendary acid house synthesizer. It has a particular flavor of filter, and it has a particular flavor of squelching waveform generation that is very tasty if used properly. It makes some very nice noises if you use it properly, but instead, they do it that way. Everybody blows these things up, and then I end up with the dregs. So Dave blew his up. I don't know, he was on peyote or something, and he decided that he would plug the synthesizer in correctly, and then it blew up. And then I was on peyote or something, and I decided to plug it in with header cables, and I plugged it in wrong, and I think I blew it up even more. So there's egg on my face. I'm certainly not egg-free. Then some other person internationally plugged in theirs wrong, and it also exploded, but probably in a very predictable way. So I am going to try my best not to blow this one up. I am going to try to fix it according to the documentation that we have, because people kept blowing these things up. They have a document that is very specific about the chips that I need to replace. I'm going to replace those chips all at once, which is part of actually what that document say. Replace them all at once, or else the whole problem isn't fixed, and it'll break it'll break the good chips again. Like, I don't know, whatever it is that grinds them up. So this board, I think we need to replace those parts. And then I have explored this circuit to the very bones of the circuit. We took a picture of the front, we took a picture of the back, I overlaid the two on top of one another, and we have a reverse engineering effort that's going on this thing that I haven't worked on in a little while. This is a lot of project that I've just described to you guys. But in order to test this, I kept trying to fix Dave's 303, and I kept giving it back to him. Or sorry, I kept giving it to him fixed, quote unquote, and he kept bringing it back to me saying it still does not produce audio. So I need to test the whole thing, not just using the sensitive and purely electrical testing machines that I have around here. Instead, I'm going to wrap that all into one thing. And this one thing will produce all of the different flavors of modular synthesizer signals and be able to analyze some of the signals coming back out. That should hopefully give me a little bit of an edge in getting Dave's working again. I think this one is going to be just a matter of simply doing what the document that we have says to do, which may mean I need to order chips, who knows. But in the meantime, I've decided to have a little bit of a mental breakdown while building this thing, because our testing module is extensive. It's a piece of test equipment, it's a piece of one-off custom test equipment, so it should naturally be built free on a perforated prototyping board. But that's not really the case. Synths are cool, synths are black magic. Yeah, it's I need to read up on those transistor oscillators, the things that these guys have, where they use matched transistors and somehow they get like an audio waveform out. But anyway, so I started building this thing in perforated prototyping board. And it was going okay. It's just that there was a little bit more troubleshooting than I thought there had to be. And then looking at the circuit that I was building, I'm like, this is big, as it should be, right? You do perforated prototyping board, things should be big and spread out. And it said, this is a lot of big stuff, and wiring this up is going to be a real pain in my butt. You know what? It's easier to make a circuit board. And I just kind of I tried to resist the urge to create a circuit board, but in the end, creating a circuit board for something like this, it's not that it makes perfect sense, because it doesn't. It doesn't make perfect sense. It is me giving up. It's looking more fun than me busting my hands apart, and it's not going to be as quick. If this were a simpler circuit, it might make more sense to just build it, right? Just right here, because I've got a ton of parts. But I think what we can do is design in CAD a big circuit board, and then my circuits get a little bit more organized in where they are. So it made you happy, though. I don't know. I like doing the hardware stuff for sure, but designing and building a circuit board is way easier. So let's get into building a circuit board. My logic is somewhat scatterbrained, and I haven't totally put together all the reasoning behind it. But in terms of interface, here's all of the interface of the circuit board minus the screen. This would be all the tactile buttons, all of the LEDs to give us an idea of what in and outs are happening, and the encoder. So the encoder's over here. We've got pin 1 and 2, A, B, and then common, which is A1 by 3. I don't know why that's the symbol for that, but you mean designing a circuit board is making me happy. Well, that's good. That is good. But I'm concerned about whether or not we can fit our entire design in. You see, the design of this thing started as screen und buttons, right? Screen und buttons, and then I expected there to be a big daughter board for the whole thing. And the design's kind of evolved from there, just because of the size of all the modules. If I am to fit this in just a single, hey Copper, what's up? In just a single module form, I'm wondering if I can do that. If I could just have this board be everything. It's possible, though, that I think it may have to be 2 boards. It may have to be 2 boards on this, which is kind of annoying. Following my intuition. Follow my nose. It always knows. Maybe this has to be screwed in with standoffs. I only have 2 standoffs here, though. Maybe this has to be screwed in with standoffs. I don't know. Or maybe it needs to have some of these plugs. So we'll figure that one out. Let's see what we can do here. We're basically on the first step. The first step of building a circuit board, which is the mechanical stuff. We need to get the mechanical stuff squared away so that we know what we're building into. We have our scratch notes for the schematics and what we want to actually get done with the board. That's the power supply. We don't need to worry about the power supply. This is just the ins, outs, and the digital portion of it, with a little bit of a word towards pinout for the the screen and the MIDI and stuff like that. So plans to go to Montana. Oh, I see. Oh, sorry, your plans got canceled. Did the West Coast didn't get Northern Lights, did they? I saw a bunch of posts from last night from all over the East Coast, people seeing the Northern Lights, and I went out to go see them. I went out to go see the Northern Lights, and I'm staring up at the sky like an idiot. The street lights around here were too bright. We just could not see it. So there's a couple circuits that we need to get to know in a minute once we do the mechanical stuff, and that's these add-on boards. The PCM 5100 is the chip that's on this board. The circuit is configured in a particular way. I need to figure out if I need like the microcontroller to configure those in a particular way. I forgot I'm in Vancouver. What? We did. It was bright enough to see at least the reds with the naked eye. That's cool. Yeah, we didn't see the greens or the reds or anything. I just saw like gray. I saw light pollution is what I saw. So, in terms of getting the mechanical stuff together, we don't need to do any of the circuits in Fusion. We ended yesterday after I got this part done, the encoder, right? And the hookup of the encoder is very simple, but the mechanical stuff of the encoder is very complicated. We have our diodes, we have our buttons, we have our plug inputs, right? And those are going to be hooked up in a particular way, but right now I just need to represent them on the 2-dimensional board. So we are going to, for the first time, we are going to click switch to the 2-dimensional design. We can switch back and forth. It's more cleanlier. It's cleaner if we just click back and forth using the buttons in the UI. You can click on the tabs for the different things because it does just open it up as a different tab. I just like switching using the thing because it forces a refresh. So if I click switch to 2-dimensional design, now we have the bread and butter of circuit board creation, which is this gray box that represents all of the layers of the circuit board displayed all at once. And we have our components over to the left there, just kind of thrown in. Now, this circuit board is a particular dimension, and we need this dimension to agree with the dimensions of our actual physical circuit board. Since the design is done in kind of a weird way with this one, we have a perforated prototyping board, which is sized to precisely the size that we need it to be for modular synthesizers. And we already have the 3D prints that will define where all of the holes and stuff are. Actually, we need to add 2 parts to the schematic, and that's the holes. So let's actually add another part. I forgot one part. We need 2 holes. 2 screw holes, and these are the pan-headed laptop screws that I really like using. You can get the kits on Amazon for like $15, and they're good-looking screws because they've got that flat top. They're not like a rounded top. I don't like the rounded top screws. They don't catch the light right for me. I know that sounds very pretentious, but it is true. So I'm going to and there it is. I just I guess it is mechanical. So we're in the mechanical parts, and in the mechanical parts, I should have standoff holes. So the standoff holes have different tolerances, and this is a number 4, Phillips buttonhead screw. What is the number 4 in millimeter? The English sizes, I don't know why I even have that. I should have different metric sized holes, and I guess, can I just put one? Can I just put one in? Is there like a... No, it's like you need a part. You need a part in order to... Oh, damn it. In order to put a hole in a board. Trim pot, switch, SC tactical standoff. Yeah, unless there's a different different library that I need for this. In the past, I've actually used other libraries in order to do the mechanicals, not my own. There's like a... Where is that? Probably just search screw. That's the Wago connectors. Let's do metric. Terminal splices. Not quite what I'm looking for. Yeah, I feel like maybe I need to make a metric screw library, huh? I forget what I used in the past. I actually had, but let's look at Phillips number 4 and see if that matches up with our screws. We'll see if we could just use that lazily. Don't want to spend too much time on everything. So, metric screws, Phillips head. Now, I'm looking for number 4, but I put metric in there and that confused it. Excuse me. I'm looking for number 4. Number 4 is like a screw standard. And not a fucking AI answer. Good Lord. Here, number 4, major diameter in inch, 2.8 or 0.1120. So that's the major diameter. The major diameter. 2.8. That's almost a 3 millimeter hole. The screws that I'm using are which ones? Oh yeah, it looks like I'm using much smaller ones. But then again, the big hole is okay. Let's check what the... Actually, wait, I can check the diameter digitally. I can do this with digital technology. Yes. Because it's just whatever I printed. Is it open right now? I don't think it's open. Where's my front panel? There it is. Mod test mod pan. Open that up, CAD. Use all my memory. Get in there. All right. Bonk. Bonk. It's already wanting me to lock down positions and I haven't touched anything. I didn't click on anything. Weird. 2.3. So our hole is going to be 2.8. So, you know what? That works out. I think that's perfectly fine. Never enough memory for the workstation programs. Fusion's okay, actually. I'm not mad at it. So yeah, okay. So that's the Phillips number 4 is going to work just fine. It's a little bit of a weird size, and we're just basically ignoring the fact that I haven't put all of the correct size stuff into my program yet. It was bright enough to see at least the... Oh, I already got that one. Shows up for the rods in gray. They don't care. I love circuit boards. Learned that the new Windows 11 updates made recall into a core system requirement for file... So recall is now a core system requirement for File Explorer due to a relative uninstalling it and needing to go into the OS repair to fix it. That's... Windows 11, I removed so many things from. There's so much bloatware in that. Oh, it's just nasty. Nasty business. Nasty, nasty. All right, so anyway, we have to locate all of this stuff on our circuit board. All of our parts are sitting separate from the board itself. So I'm going to bring back in this IO PCB because we're going to be pretty much replicating it, right? And so, but without the weirdness of perforated prototyping boards. So I need a measurement from this face all the way over to this partially cut face. And I want to go to the way outside on that one and just get that one. 98.4. It is such a specific dimension. And in circuit boards, they don't care. I would have made it a round number, but this is just going to be a terrible number. So this is going to be 98.4. And this took me a while to get to. So we're going to one panel attempt. So 98.4 width. So I'm click on this line and hit properties. And then the two numbers that are the same are our width. So 160, and I'm turning into 98.4 for both of these. 98.4. 98.4 is actually good news. That means we're below the 100 by 100 millimeter requirement, which means that these are going to be $5. So I'm happy that I can source this board for $5. Due to how recall is, I doubt anybody who has an NDA or something else for their work, especially government or healthcare work, can use Windows 11 and stay compliant. Ugh. They want all your data all the time. We want to make sure that every click you're making is logged and retained by our Department of Monitoring so that we can somehow lie to you and say that we're using your data in order to improve your experience. 46.3 is going to be the other main dimension. So 46.3. So go over here, properties, and that's going to be at 100, 100. Let's do 46 Mark III. And the other one, so that we don't have a trapezoid, 46.3. And that is the size of maybe the entire project. It's possible that I'll make another circuit board that's about that same size, but they just want to sell you hot tubs. I didn't know about that. Maybe I need a hot tub. I have a friend who has a hot tub. I never want a hot tub. It's just, I don't know. You think about all the times you're going to be in the hot tub, and it's probably like 4 times, and then you have to maintain this thing the rest of the year. They were using data to improve the experience. They learned to go back to Windows 7. Fucking hell. They would turn everything, like, get all your bloatware on a marketplace, right? Put all the bloatware on a marketplace. All the bloatware, the calculator app, everything on a marketplace. Reduce your operating system to just operating a system, for Christ's sake. I'm so sick of having to get rid of so much bloatware. Put all the advertisements on your marketplace. They're going to go there. They want all that core functionality. Yeah, a lot of work, a lot of energy. Do you keep it at temperature all year? It seems a little psychotic to me. We are looking down through the circuit board from the top layer. So we need to look down through our circuit board from the top layer. We need to use our J's, our R's, and our U's, which are not featured on these parts at the moment, in order to figure out which one is which. We could at least use D1, the D's and the U's, and then well, U7 isn't going to help us out, but maybe the ordering of where these things are located will help give us an idea of which one is which. We could probably also just click on it, and that says J6. This one says J5. I really hate that info window, and I wish there was a way to disable it. Autodesk Assistant. Oh, hell no. Close. That little info window comes up at the weirdest fucking time. I'm so mad at that info window, that little info pop-up. When I right-click, it comes up. Get this out of here. There's a properties window. Yeah, okay, J5, J4. Okay, so I can get it through that. So we need to position these in an XY grid, because that's what this whole thing is all about. And we know where everything needs to be located. So bottom of the circuit is there. The bottom left-hand corner is 0. We need to give everybody else coordinates. I clicked on the wrong thing. So the coordinates are going to be based on my 3D model, which is based on IRL, how this thing got together with perforated prototyping board. It spreads things out just a little bit more, but still. God, if it was clippy, I would be even madder. You can't turn off that info pane. I tried looking up how to turn it off. It's so disruptive, and it comes in like 3 frames. Look at how, well, okay, instead of just bitching about stuff, I need to actually build. Okay, so we need to somehow theoretically figure out what the center position of an LED is. The LEDs are going to be grabbed from a center position. It looks like maybe I could use part of the toilet bowl. By the way, with an LED, this isn't a typical construction. They kind of tried to replicate a typical construction with this part. This part I got from GrabCAD, and it's kind of split in half, which makes it a little bit difficult to work with. But with an LED, you have an anode and a cathode, and typically the the cathode is the toilet bowl. And if you look inside of an LED, you'll see a little toilet bowl. So the toilet bowl is the cathode, which is the minus, and the anode is the little, I don't know, whatever, the pokey bit, this thing here with the wire coming out of it, and that's plus. And then to differentiate, your plus wire is longer than your minus wire, which I always think is kind of a little bit of a bullshit way to identify an LED, because the first thing you do when you solder it into a project is clip the leads off. All this is there for is to ease an assembly. If you're hand assembling through hole, the reason they make one pin longer than the other is that you seat the one pin and then you wiggle the LED in position with the other. Surface mount LEDs have other markings on them. They have their own ways of marking. You can't really necessarily see the inner workings. But then on a through-hole LED, you also have a flat spot, and the flat spot denotes minus. So there's the flat spot, there's the cathode and anode. Yeah, and that's typically the way you do it. You look for the flat spot on the 3mm and the 5mm LEDs. Any other LED, if you have trouble with, just get the multimeter out and put it into diode mode. When you put it into diode mode, it gives you the voltage drop across an LED, and if you are able to achieve getting over the voltage drop across an LED with even just a tiny, tiny bit of current, it should make the diode body actually emit light. And so you actually get to see the orientation of your LED's leads by using the diode testing and putting it in positive and negative or negative and positive, and it'll light up. And that's how you tell the color of an LED if you've got a pile of clear topped LEDs. So these are calibrated to be a particular height, and that's the height of the Donkey Kong connector. And I think that's what I did with my other parts. They are the same height as these connectors connect to the front panel. That way I can put them in and put the front panel on and then solder them in place, and you have LEDs poking out of your front panel. Position-wise, we need to figure out where they come in terms of this corner here, the bottom left-hand corner of our circuit board. And we are going to have the LED body, but we need the center of the body. This thing ain't round, but there still might be a center point on it. So if I show that, there's 2 points in the center. Let's see if we can get Fusion to cooperate. The difference between Fusion and Blender is the ability to manipulate the camera. I found that the ability to manipulate the camera, this is not the answer that I wanted. The ability to manipulate the camera is much more natural in Fusion, is my opinion. Blender has you dragging your center point around, and it doesn't refocus the center point, which causes problems for me. Other people may not have problems, but I have problems with it. Okay, so our first LED is positioned in 43.82, 9.33, 43.82, 9.33. E1 properties. 43.82. And then positive 9.33. And that's rotated to the side, but it doesn't matter because we centered it on the circular part of the LED bottle. LED bottom. There we go. I need to get like a Harrier Dubois outfit for Halloween. Probably a spoiler if I say that. I shouldn't say that. A Disco Elysium outfit. All right, so these are all going to be on 43.84. So I guess what I can do is I'll just get them vaguely into position, and then we will correct the height of them. Because this whole thing is in a grid of sorts. Properties. And then 43.84. I'll cut and paste that into all of them. Do, 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 do. 43.84. It's off the grids, and I don't know what to do with the grids. I need to metricize the grids so that everything is metrically located on their grid, and that way all of my traces will be a little bit cleaner as a result of that. That, or I just get a freaking AI to do all the work for me. Probably what we'll end up. I don't trust the circuit layout AI. I don't trust it. Okay, so each of the vertical ones is going to be their own grid, and then let's get those in. If we've got a good way to measure it, we can get those vertical columns in, and then we can do the row heights, and that'll give us all of our stuff. So I'm going all the way back to, let's get this one out of here. We don't need our library manager to be up, and that way I can click on the tab at the top. That makes it a little faster. Yeah, so we've got a vertical and a horizontal like grid layout here that I just need to ascertain what the locations of it are. And I got the nice easy LED body to give us the one column location. Oh good, we're peeking out of a hole like some kind of a creeper. I see you from the via. Accessing the bottom of the LED is the difficult part. And I can't click on anything because I am in a tool right now. I both am in and am a tool. $43.82. Did that change from the other one? Or did I get the wrong thing? Or are these not located correctly? Well, let's get the other one in there first. 22.03. Why is it negative? I don't understand why my CAD thinks it's negative. 22.03. $22.03. AA MCO. All right, next. Measure from here to number 3. And if I can get all the way over there, highlight that horseshoe, hit Control, that little nubbin is what we're after. I like how it does the crow flies as if that's going to be a useful measurement in any sense. 34.73. Which one is it? This one? 34.73. There we go. Next. So when we're done this, we can actually take a look at the rendering of the board and pull it into this document and compare the two. That'll be neat. 47.43. $47.43. I wish there was a way to pull numbers from tab to tab. Wait, which one were we on? 5th one. Ugh. From there to see, when I do those scroll marches like that, it doesn't mess up the speed of the camera's panning, but it will do that in Blender. It'll mess up my ability to swing right and left with the camera. 60.13. One of the cool tricks about designing circuit boards is that we're designing something that's smaller than a piece of paper. And pieces of paper have very accurate printers, printers for them. So what you can do with the precision of a circuit board is you can do just a printout, and then you take all of your components and you act like they're like micro machines, and you place them on top and you make little revving noises. But you can place all of your components on top of a piece of paper, and it will give you an idea of the dimensions of your design. 72. Why do they always put the number in the hard to read spot? 72.83. There we go. So 72.83. Let's locate the encoder too now. The AB encoder. So we're going again from origin to a center piece of this thing, which I think is the, uh-oh, there's 2 here. We got to go from the hoop, from that. There it is. You know, Fusion, you can put like a little thing around the number. Maybe that would help if you put like a little, just like a little ghost thing behind the number so that I get a contrast on it. 88.82, 88.082, 94,993. That's the wrong one. 88.082, 2779. 8882 2779. $88,882 27. Come on. What the hell? 2779. There it is. All right. And then these facing this way. Or do I want ground to be on the outer edge? No, I want them facing this way because I don't think they're going to fit otherwise. Oh yeah, and then I need to make sure that they're the right ones. J3 would be channel 3. There. 4. 5. I'm right-clicking and looking at that info panel. If I can't turn it off, then I might as well use it to my advantage. 1. Ah. Yeah, I mean, if I were designing the circuit board from scratch, it would be way easier for me to align all this stuff properly, but which one was that? 2. 6 by default. And then I can use the names on this. I'll probably get rid of the names on the final design, but you don't really need U's and C's on certain things. Okay, and now we can just take the properties from one to the other. So this one is at 4382. No, 4382 is the column, 9.3. And then let's figure out what the column height is. That one has a nice round thing on it, so I can get my center very easily. So measure from there to there. Get the XYZ. 25.61. $2561. Yep. And then now the connector, and that is going to be that's a tricky one. These Thonky Kongs are asymmetrical. So where's our grab point on these? It looks like it is the center of the plug itself, which lines up with this circle up here. So I can use that circle up there and get a good center. For the number of times I iterated through this design, if I had started with a designed circuit board, I wouldn't have had any of the troubles trying to iterate how this thing was going in conjunction with the holes, the perforated prototyping holes, because it does fit into a perforated prototyping board. You could perforated prototype with Thonky Kong connectors all day of the week. Getting that specific alignment was very tough. So if I do it again, I'm going back to this CAD drawing in order to figure out where my connectors are. 5.87, although it's baffling why everything is negative. Can you 3D print from Fusion 360? Your question made me forget what the number was. Hold on. Yes, you can. I use a different slicer. I don't use, I think Fusion might, does Fusion have a slicer? I know they have you can coordinate with another program and you can have it be a button you hit. But yes, everything that I do here pretty much like hinges on 3D printing, whether it's FDM or SLA. I don't know what that, whatever. 5.87. If it's goop or poop. Goop or poop printing. That's how I do all of my custom front panels for everything. And the 3D model that you're seeing corresponds to this board right here. And that's this board. And then I figured out where the holes in the front panel were based on it and a bunch of different iterations. you can export to STL. See, that's pretty much what I do. It's just, there are so many buttons. There are so many buttons that I don't know what they do. I think Fusion does do, like, machining, the automated machining stuff. But with 3D printing, you can take a body and you can export it to STL, and then you take that STL and you can throw it into your slicer. Or I think there's a way to get this to work with whatever slicing program. I haven't explored that yet. It does have a slicer, I see, but it's not very good. Well, 5.87. Let's remember that number for just 1 second here. Properties. This one is in... Oh, crap. Which one is it? It's the second... No. Yeah, it's the second number. 5.87. That didn't look like it moved at all. It didn't move at all. The height is supposed to be 5.87, but I guess 5.87 puts it off the board, which doesn't make any sense. I see. It puts it off the board by like a barely measurable amount. And if I add more distance here, this is origin. So I need to actually add or subtract distance from these to move them down, because technically I'm adding material. I'm shifting the board to the right just a little bit. Do they actually stick off the end of the board? No, they don't here. These my measurements are a little weird. I see. Yeah, Mesh Mixer. It used to be, people used to talk about that program. I don't hear about it anymore. So let's see. I have a choice here. I mean, I guess I can have it violate its own rules. I don't understand why my 5 point... Let me remeasure this and just make sure that I don't have a batshit number. From there... Oh, let's get rid of that there. From here to here in this one. 5.87. Can't really deny that. $5.87. It won't do it because it doesn't let it get near the edge. There's a design rule that doesn't allow it to get any closer to the edge. So I need to get rid of that design rule before I move on. I don't know how to do that, actually. Wow, that pad hole violates a rule. So let's just quickly, I'm just going to Google it. It might be a DRU rule, but pads near edge of board. It's a strange one. So I guess we're going through the DRU. I think that's what we need to do. So we go to rules and we go to design rules. Pad clearance, or are we talking board edge? .02 millimeter. So 1.02 millimeter. That's clearance between any copper object and other objects. So let's do, like, why doesn't it display the whole number? And yet I can't do the normal click. God, why are you like this, program? Oh, and then if I click right too many times on the arrow key, it bumps me out of the number page. Autodesk, blah, 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 blah. You can set up Fusion to open the STL version of your model in your favorite slicer automatically. So minimum and maximum board outline clearance, and the rule's 1.016. Let's just make it 0.05, just for funsies. And then it was 5.82, I believe was the number. I hate remembering these little numbers. It's like that just pushed an important fact out of my brain, and I will lose an argument as a result. 5.87. It still doesn't let me move it. Some other rule is being violated here. How close did we get? It did let me move it a little bit more. It's still 7.026. Son of a bitch. Preferences. What's that about my annular ring? Layer stack. No, that's all normal. It's just the rules. Board outline clearance is how close it gets there. SMD clearance, no. Via, no. Via, rather. It would be board edge stuff. Copper restrict, no. Drill clearance, that's drill to drill. Copper width, drill size. Acute angle. Huh, that's kind of neat. It's disabled, though. That's kind of a neat one. Match signal lengths. We're not doing match signal lengths. Yeah, I don't know which rule we're hitting here. Preferred. So let's just take out the preferred and let's make it 0.5. Try that. Well, that got us closer. Where are we now? We're still a millimeter off. I mean, at the end, I'm going to add a millimeter to all of these, but I mean, we're going to take it, let's take it down to like less than 0.5. We just got to remember that we changed that rule. and I don't know what the parameters are for Seed Studio. They might be different than what those rules are. I need to calibrate them to each other. .87. So that really gets close to the edge there with that pad. If I were to add a millimeter to the height of this thing, we're getting close to the maximum allowed distance for what is it, for modular synthesizers. I think we're very close to it, in fact. So if I measure from one extreme to the other, that's 108.5 millimeters, and I think the maximum height is something like 110. Which, I mean, means I probably have a millimeter to go. Let's see what the physical thing actually is like. Put this 303 aside. Make room. Oh yeah, it's like touching on both ends, but I could scooch like a millimeter out of it, and that would make my design rules a little bit happier. Let's see here. Although I guess this isn't exactly placed. These rails are not exactly modular synthesizer compatible. Let me go see on the actual rack how it fits in. How it fits all the way over here. I think Julian's rack is magnificent. I mean, close to specifications. Oh yeah, there is not even a millimeter in that. That's maybe a millimeter, maybe 1 millimeter on either end. But that I don't want to scooch this circuit board around. I want it all to fit in. So let's take a look at what Seed Studio's board requirements are and see if maybe we're fine. So we take a look at, I gotta get my mouse speed back. There we go. These mice with their 2 different DPI settings. Seed Fusion Design Rules. Since when do I ever want a fucking AI to respond to something? AI has been proven to just make stuff up. And like, why would I do that when I can just go to a primary source as the first link? Jeez. Minimum trace spacing, minimum trace width, distance between holes, annular rings, inner layer copper, drill hole diameter, plated hole diameter, CNC milling, width of solder mask dam, BGA size, cutout edge, that is the worst image I've ever seen, minimum distance between inner trace and plated holes, silk screen color, pad to screen clearance. V-cut, V-score, V-groove, production time. What about board edge requirements? Control F, edge. Oh, circuit to edge. Greater than 0.3 millimeters. Oh, that's damning. 0.3 millimeter, huh? I don't think we're going to be able to do that. Well, not with this current layout, but if I put all this stuff in position and then scooch it all up by the same parameter, I think I should be okay. So we're gonna have to come back and revisit some of this. Now, can I use some of these layout tools here? Aren't there? Hold on. Can I? I thought there were tools where I could just click on stuff and it would line it up. Well, there are pattern tools, and I guess maybe I could have used the pattern tools in order to put that stuff together. Yeah, routing, polygon, unroute, rework, modify, align. But what does that align? I don't want to lose some of the numbers that I've put in here. What's up, crazy boy? No, I think I just got to cut and paste numbers in order to get it all right. So let's see, this one, these all have to go to 5.82. It still ignored my number. So apparently 5.82 puts this thing outside of the PCB. It puts it like there. That's going to be in like, that's 3, but somewhere in between there, my pad ends up being, oh, it just misaligned it on the grid. It's important that I get these positions correct, but it seems like I need to slide that part of the circuit board down a little bit. Static roots. In a networking class, we're building a circuit board. We're building a circuit board based on the physical board that I've already produced. And it seems as though I have violated design rules, even though I don't really think that I have. But it seems like I need more circuit board to stick out of the bottom of this thing. And I'm trying to figure out how much I can actually have sticking out. So if I add a millimeter and I turn the edge cases into 0.3, I guess what we're going to do is I'm going to take this and I'm going to add a millimeter to it. So 98.4 becomes 99.4. Or no, 46.3 becomes 47.3. That's a weird number. But that should hopefully not affect our stuff. Now we add a millimeter to the position of everything. We add 1 millimeter to the vertical position of everything. So instead of 43.82, it's at 44.82. It's a very clunky system that we have here. Is it 8.2? Let's double check. These little numbers that I fudge are going to be a problem if I'm not careful. Yeah, 43.82. So it's going to be 44.82. So 44.82. Okay, so we had the right number. So let me just correct these. Yeah, it looks like I swapped in an 8.4 instead of 8.2. 44.82. What this does is it lines up with the panel that I've already printed. I've already printed a panel, and I know what size board I need to use, and the positions of the LEDs and the buttons. And I don't want to reprint the panel, so. Do I do machinist type work? Occasionally. 25.61 becomes 26.61. Funny, that doesn't appear. Well, am I not hitting Control V? There we go. These all into the right positions here. Oh, I gotta highlight the whole thing there. This is my experience with Fusion Eagles. A lot of double clicking, a lot of pasting, and maybe there are tools that will change the properties so that I can change the vertical position on something by just clicking it. I just don't know what tools those are, and I don't want to lose my numbers, so. This one's already in the right position. And then this I got to add a millimeter to. So that's 27.79 becomes 28.79. Ordered burger and KFC style chicken bites. Burger was partially raw. Ew. That's not good. Okay, so now I'm going to measure what the position of this thing is. From that corner to this here. And get that vertical. 5.87 becomes 6.87. There, that's the position that we need. There's going to be a little bit of board overhang, and I'm not sure if that's going to lead to bad things. I don't know if that's going to mean that the board will overhang below things more than it should. Hey, what's up, CDM Kellogg's? Brr, brr. Yeah, that's a big, serving raw food to a customer is a big no-no. It rarely happens because of how bad it is. You can't expect the customer to not eat something that was sent to them. You should eat it and get sick and then sue them. Sir, if you notice the burger was raw, why'd you eat it? I don't know, I'm sick. Help me. Give me a coupon. It was worth it. 7 hours of dry heaving. For a coupon. I got a coupon. Moving everything in conjunction with one another is not something that I really know how to do in the program, and I know that it can do it. It's just not really something I can totally figure out. Let's see. I think the horizontal positions now need to be done. So these need to be located at 9.33. I just need to go through column by column and get them into the right position. That one's already done. The problem with this program is that if something is a little too close to something else, it'll ignore the number that you put in, and it'll just be like, oh, no, I can't do that. It's like, wait a minute, can you just try, just because I know that that's supposed to be the position? Actually, I shouldn't have moved those manually. Here, let's go from the out. What I'm afraid is that I want to move this one over to the right to match up with D2, and it's not going to let me. I think it will, though. That whole design rule thing is great if you're designing the circuit board first, but if you have a physical design and you have to get it to the right parameters, you have to like massage everything into place properly and in the right order. Bada bing, bada boom, bada bingus. Okay. This is much like Satisfactory, but it does not have all of the quality of life improvements. They should have the Satisfactory team come in and help them with their software. Then I could have zooping. I could zoop this whole thing. Or have the AirWire alignment tools like they have in the parts making facet of this program. It seems like there's a lot of disparaging software teams. Disparate? I don't know. Wrong words. I don't have the right words, but a lot of sort of compartmentalized software teams working on different features. And a little bit of cross-feature propagation would be nice. Like having sketch tools that'll allow you to align things in your design, because that's all I used to design this. So what we did is we added a millimeter to the bottom and shifted everything up. So it'll still fit, but now we have all of this stuff in its proper locations. I'm going to hit save. Now, with circuit board holes, it can go in a couple different directions, because I think what you can do is actually extrude holes in the circuit board, or use a tool, I think, to add holes to the circuit board after the fact, like at the end of this, and it'll put it all the way back to the schematic. But we're doing it from the schematic out. Can you not drag and select two at a time? I am aligning these things based on numbers that define the X and the Y position of the actual part. So if I select multiple things and I try to move or align it, I need to know what is being moved or aligned to what, because I'm controlling the numbers directly. So there's not too many options of what I can do in terms of saving myself a little bit of time. So, all right, so those are all laid out where they are on the actual PCB. Man, I don't know if I'm going to be able to make this into one PCB. This is going to be a challenge. I can do a lot on one PCB, though. Let's just check with the design rules. If I change the design rule, it might bump all of these up, which will be kind of a tragedy. 6.87 is not, oh no, 5.87 is the number that we get on the other one, yeah. So we moved it, we extruded down by 1 millimeter. So 6.87 is their current position, which puts this perilously close to the edge of the board. But according to Seed Studio, it needs to be greater than 0.3. So in the rules, I'm going to check, and we're going to make this from 0.05, we're going to make it 0.03, which is a significant difference. And it might bump all of our stuff up. 6.87. It didn't bump all your stuff up. We're good. Whew. That is a relief. Okay, so everybody is in place. Everybody is in the place. Let's go. Let's go ahead and make the three-dimensional board out of this. So from here, again, like I say, I use the UI buttons, which maybe you could, I don't know, maybe you could circumvent the UI buttons. You can certainly do it from a pull-down menu, but I'm here to contact you about your Autodesk extended license. I got 8 days. I have 8 days to go. I either sign up for Creator Camp or I'm going to spend a long time archiving parts with the free version. I think, I don't know what I'm going to do. I think what I'm going to do is apply to their creators thing quietly with my tails between my legs. My tail between my legs. 3D geometry to include solder mask. Yeah, sure. Stop layer geometry. I don't think so. Copper texts. That's a new one. Polygons. Sure. Push is kind of a weird word. Push. Why would you have to archive with the free version? You can only have so many active documents at a time in the free version of Fusion. It's one of those limitations that they want to have that pushes you towards their paid version. So these, luckily, are calibrated at the right height. They're not as silver as the other. I don't know why they're not as silver in this. Weird render settings, I guess. It's an odd sheen on the... Maybe it just doesn't have the material that this particular LED that I used has. Okay, so our buttons and all of our things are in, and we've got the encoder in, and so we can save this as our one-panel attempt. This is where you would put holes in the board, and maybe we can do that. Create a PCB hole. Diameter of... Well, it's not letting me choose the diameter. What's the... Huh? Maybe I can't do that here. Cancel. We'll use the Phillips holes, I guess. Or maybe I'll just drill it myself when I get the board in. So let's take this file and let's bring it into this one. Oh my God, where's the file? Right there. And we are all the way over here on the timeline. I don't know why this thing wants me to stick the position. I haven't done anything with the positions of stuff. So let's bring this little guy in here. And now I can't do that corner. I can't do corner to corner on that corner because we extended it by 1 millimeter. So I'm going to do point to point, and we're going to grab this corner and go to the top corner here. And aside from the LEDs flipping, it looks like everything is just in position. It's all Z fighting. There's a little bit of fighting going on. So what's that difference there? So there's minor differences in the positions due to probably the number of decimal points that are available. Is that in a different orientation? What's going on with that? Oh, is it a different 3D model? No, I just have it flipped 180 degrees. I see. It doesn't matter what that is. Doesn't matter if that's flipped 180 degrees as long as everybody else gets along. They seem to, although the height of the part is different due to perforated prototyping board being a little bit different. About the buttons. Buttons look like they're Z fighting just fine. So all things considered, I suppose that'll probably work up all right. I'm gonna lurk and work on my DDNS for my server. That's cool. I gotta work on my server. I gotta get Mosquito running on it. All right, so the PCB for the I/O is apart from the heights being a little bit different of the components, and maybe they're not, some of them are 90 degrees from one another. They all meet up in the right spot. So if I were to order this and put it together, this would work fine. The height being slightly different is just a matter of how I modeled the other PCB. That Z height is not going to be as important as long as the boards are laying at the same spot. Because on the perf board, it probably doesn't stick out as much as I gave it credit for. And on this, it certainly won't as well. Cool. So how does that jive with everybody else? Bring these back in, and that's all my stuff. So the holes are not there as of right now. We can do that later. I may have to do it by hand if those edge rules are going to come up again. And then this sticks out a little bit further. So the distance between these two needs to be below 10 millimeters. It is exactly 10 millimeters. Oh my God, how does that work? Wait a minute. I added a millimeter and it gave me, it's exactly 10 millimeters. So theoretically, everything fits perfectly because you get 10 millimeter from the edge on a modular synthesizer panel. So, oh, that puts a lot of worry to rest. I was worried about the layout of all this stuff, whether or not it would work out. And I guess as a last ditch effort, I could maybe turn these 90 degrees. 180 wouldn't do because then this ground pin sticks out further. or I can redesign the front panel so that those are a little higher up, but I want them to be at the very bottom. So they are at the very bottom. Do you have a 0mm tolerance? No, but I mean, the circuit boards are done very accurately, so I would assume that the outer edges are going to be very precise to what is in the program, in the CAD program. I would hope. I don't know, though. I don't know. But anyway, this is now ready for the rest of the design. Am I going to be able to fit the rest of the design on this thing? No. Look at all the crap that I would have to do. Chester Willard, 4 years, 49 months. Oh my God. Yeah, 48, 49. Man, where does the time go? Chester, thank you so much. I really appreciate your presence and all of the subs and, well, giving me money. Yes, yes. Everything's going according to cake. So, that's all laid out, good and happy. We now have to answer the next set of questions. Been a while since I could actually even catch a stream. That's okay. Everybody got busy after the pandemic, you know? That's just going to happen. We need to get a Teensy 4.1 into this bish, and I know that I'm not going to be just using the Teensy 4.1 on modular synthesizer stuff. So I'm going to back out and I'm going to go to admin projects. So admin projects is right here. And in admin projects, I have 3D pads, 3D part models, 3D part no library. So for instance, some of the parts that I used, like the encoder, I'm going to have to move that into the 3D part models. 3D pads are where I have all the 3D part models that have pads on them. And Fusion does not like you moving stuff around. I'm very disorganized in all of my folders. I would like to, and I would love to at some point spend some time like reorganizing all this stuff and making sure everything still works and that I have certain places for certain things. There is an offshoot, I guess, that AutoCAD made that is a folder style browsing of all of your stuff. And maybe I should try to sign up for that. I don't know if it's free. I'm gonna burp. Okay, I burped. I don't know if that's free or not or what the deal is with it. But it would be very useful for me to like get everything into organization. Because like when you do a 3D part and it ends up being like a manufacturer part, you have one file for the 3-dimensional part, but then you have the same... Oh God, why is this so slow? What is going on here? What are you uploading? Wait, what's going on? What the... If we lose work on this, I'm going to be very annoyed. Why is this locking up when uploading? We had this problem yesterday where I tried to upload other parts and it would just mess up. So is something going on with my account? That was my theory, is something is going on with my account. And when it tries to upload, it goes, oh my God, you have so many unarchived things. Because part of it is in electronics design, you have a lot of stuff. If this fails to upload, I'm going to be very annoyed. Yeah, but anyway, you also have 3D parts that have pads on them, and they're the same parts. Feels like GitHub, but dumber. I don't know what GitHub is like, but like these are all the same things. It's just that I have different pad variants on all of them. And it's like, why do we have so many wasteful files? See, this is how I do modules. You have the 3D file for the module, and then I add headers to it, which are separate models. So anyway, what we need to put in here is a model of the Teensy 4.0. And the Teensy 4.0 has plenty of models for it. So if we go with what I know, we go with GrabCAD. I had so many windows open. Somewhere in here is a Teensy 4.1 model. Somewhere deep within. All right, we already got that stuff. We don't need to worry about that anymore. We don't need this anymore. Mutables were good. Those, for some reason, those would not upload. They refused. There's GrabCAD. These I don't need. This I need the part number for. This I need the part number for. We're going to be putting these chips directly down on the board, and then I'll be using hot air to pluck the chips off of these boards. Because this is $13, right? $13 for 3 of them. Whereas if I go to DigiKey and I order them and I only order 3, I'm going to have a $5 unstocking fee. Depending on whose GitHub you have, it can be a real pleasure with structure to it and nicely laid out README, but others can be a total dumpster dive. I need to upload my stuff to GitHub, and it's going to be a complete dumpster dive. I don't look forward to it. I wish I was very organized with my... I started out thinking that all of my project directories would have the same sort of hierarchy. And I probably should stick to that, but then that would mean on projects where it's purely hardware, there would be all of these extra folders, and you'd be going into hardware, and then there's like one design in the hardware folder, or like one bitmap of a penis. Just one bitmap with this schematic on it. There it is. Just that right there. Probably true with CAD stuff too. My experience is the latter. All right, so this looks like a pretty good model, aside from the fact that the SD card is not shiny. But if it looks like this in the CAD program, I'm pretty happy with that. Let's go ahead and do that. So download the files. Damn it! All right, I gotta log in. Promise me you won't get all of my credentials from the reflection of my glasses. I have to maintain a distance between me and you. That's my job as a streamer. Until I have many, many fans, and then we can get all smelly at a convention, and I'll get whatever cold everybody else has. All right, this'll do. This'll do. Not cool enough for that. Where download folder? DNC 4.2 snapshot extract. And then, oh my God, look at all these files. Holy shit. Solid assembly, I think, is what I want. But that might require to have a whole bunch of solid parts with it as well. We've had easier times getting these things in. I tried to keep one of my HDDs totally sorted, end up sorting it, and never to be seen again. I try to keep my downloads folder sorted, where if I download something and use it, as soon as I'm done, delete it. And I kept that up for a little while, but now they're just... The downloads folder ends up being this like weird sort of sedimentary diagram going back to the Dark Ages. And you're like, ooh, they had a fire then. You can scroll down by date of all the files that I have in downloads and go, ooh, oh, he broke his computer then. He did a memory scan. That's when he downloaded whatever that program is. All right, so we're going to put this in 3D part models, or is there one for add-on boards? It's just going to be 3D part models. But the other ones are in 3D pad, but 3D part models, I have the assemblies with headers in here. So I'll go in and I'll pull headers into the ones that yeah, it's like a drill core, like a ice core. So let's see if the solid assembly pulls the things with it. Actually, which one's the largest one? The step file is the largest one. 15 kilobytes. Solid assembly probably incorporates a bunch of those parts. And I don't know if putting this in there is gonna... Let's hit cancel on this. Maybe we make a folder for these. New folder. I'm just gonna call this TNC 41, just in case it has to have a billion files with it. Solid aslam. Please select the required reference parts and subassemblies, and it doesn't give me anything that I should be including with it. So is everything that's a solid part coming with us? Or maybe I should put, but if it's an STL, hold on, let's retry this. Before we do the solid assembly, let me pull in just the step file and see what that looks like. The step file probably does not include appearances with everything. But it is 14 megabytes, so if it looks good enough, I'm gonna use that. I don't need the solid assembly. I don't need to copy the TNC's parts. The TNC exists in an the TNC goes to places that I cannot follow it. I'm sorry, little one, but I cannot follow you to these places. You've gone into too dangerous of a forest. I don't mess with SD cards. I don't fuck with surface mount parts that are this small. It's just not my nature. I can't do it. I can't do it. There's so many. Look at these. Look at the size of these capacitors. It's impossible. I cannot do it. So yeah, it's okay. If it looks proper, then I'm fine with it. Let's take a look. Oh my God, it's got all the parts. Yeah, this is what we wanted. This is just a singular file. And it's everything we want and more. Cool. All right, so I'm going to move this out of the folder then. And then we will reposition it and add pins. This is all I need. The little bits are pretty much just like added extras. If I wasn't able to import a Teensy, I could make a circuit board that has the 0.1-inch spaced holes, and I would simply put a USB plug, the main chip, the button, and the SD card, because those are the things that I interact with as a primarily meat-based human being. Those are the things that I touch. Much like a drill core. Oh wait, no, you already said that. Sorry. There are no traces in the view on purpose. No, there are no traces on this because this is for positioning this product. It's not for making this product. If it were for making the product, it would have traces on there. But for the purposes, the purposes of this model are to add it to whatever you're making, so you know where all the hole positions are, and you know that it fits, and you know that stuff isn't interfering with it. This is not for producing your own circuit board. That would be a really thrifty, weird way to do things, though. You steal somebody else's entire thing and you take all their traces and stuff. This looks like there's something more to this. Like there's like a shadow of an SD card sticking out there. I think maybe the original part had a piece of plastic that would be used to have the machine plop it down in the right location, and then that plastic gets removed at the end of the process. So yeah, this will do. Holy shit, it's a lot of components. Let's move it, and we'll just move it up one directory. 3D part models. There are just so many pins to this thing. All right, so while we are here, what I'm going to do is I'm going to take this. Actually, I'm going to take, oh God, I need to take all of this. Ugh, look at all this stuff. Ugh. Move it. $90. And then bring it up. So the model looks okay in the part preview. And it's a little easier to work with like this. Okay, so we've moved it. I guess there's no history on this. We need to add the headers to it. And so in order to do that, I don't know what I'm supposed to do. Hold on. Do I need to make a separate header, or do I repeat a singular header? We've done some designs with the Teensy 3.2. That's what this is. I should probably get a model for the 3.0. Yeah, so I just take the individual headers and I move them into position. Where's the headers? The headers are on this file? They are not. Probably in 3D part, no library. Yeah. Here are those magnet connectors. These things are great. So yeah, here's our header pieces. And so we can go into, oh my God, it's going to be so many repeats. Oh boy. All right, so let's bring this in. That's the wrong one. Bonk. This is going to add so many parts to this part. It's ridiculous. So the position of this one, based on that, goes here. All right, that'll do for that. Bring in this one. And now this one I need to flip over. Okay, and then I'll take this edge, and let's see where it goes. Does that go? It doesn't go on the tip of the cone. It goes, well, we'll give it a little tiny space there like that. Just a little bit. Which phones went for pogo contact connectors instead of for wireless charging? I don't know. I like the wireless charging. I know it could be faster, but I think just plopping it down on a cradle is fine. It means that stuff won't short out your contacts. I found out that my USB-C connector in my phone, my Android phone, it can detect water. So I guess they're looking at the, and this must be like the whatever USB chip they're using probably has this feature where it checks to see if there's capacitance between its pins, and if something is off, it'll say. And I got a pop-up menu, like message on my phone that said, there's lint or water in your USB-C socket. And I'm like, that is clever. Having the ability to actually detect water, I mean, that's a thing, right? You can get those little water sensors that you put in the soil. They, of course, corrode and they become kind of disposable. But like with contacts that you have to the outside world, you can do the same thing and actually detect whether or not there's water in the USB-C socket or if like conductive lint is in there. That's cool. I like that. And the fact that when I went and I blew out all the water, because, you know, when I get down to blowing the sockets, things get moist. No, let's not go that route. Anyway, I blew all the water out of the socket, and then it went, oh, it's clean. And then the alert went away. It was awesome. Why is there still an uploading dialog down there? Probably because all these failed. I can't do anything about it, though. Stupid Fusion. I'm gonna burp. Oh, this one's deep. It's like real deep down. My Stream Deck froze. I have to start the program again. Stream Deck has been kind of freezy lately. It's probably more indicative of the health of this computer than anything else. Oh, and now I'm muted? Now you mute me. Now I'm muted. Now I can't talk. Oh, there we go. It went back in. It actually figured it out. I am not muted. It just showed me as such. Cool. Okay, so mute works. All right, so we need to repeat this how many times? Jesus. Look at all that crap. 1, 2, 3, 4. I just thought you had a sneeze attack. Okay, so because I have to squish my Fusion down to fit with all of my giant vanity windows, I really need to have a vanity window view, and we need to come up with like a V2 review where I could be this little thing in the corner so that we have an actual like vast amount of room for me to do this stuff. I mean, using the squished up window is all well and good. It just means that I have so much less real estate to do the CAD functions. So what we're looking at here is like kind of confusing. It's like all these parts to the left, and then we've got this massive tree, which I could collapse actually, and I probably should. Collapse the massive tree, collapse the thing of parts. There, finally we have the sacred view window in all of its splendor. Weird that it happened at the sandwich place down the road. What are you... are you just trying to riff? Okay, so I got an ad for TI's moisture detection system using USB-C, which seemed odd since I don't work in a design job. I just don't work in general. That is funny. Why would they? Maybe because I'm talking about it, some of their monitoring things are confused. So let's select these headers. No, not that. Let's select these headers. And now I'm going to do a pattern. So create, and then I'm going to do a rectangular. Let's just click the button up here. A rectangular pattern, and the direction. Object type components, objects 1 selected. That shouldn't be 1, tube there. Is this is a square pattern? The axis would be that way, right? Yeah, there we go. Okay. All right, so we're gonna do spacing, and it's 0.1 inch that we want in between. So the distance is gonna be 0.1 in, and Fusion is perfectly happy to work with 0.1 inch spacing. It loves it. So how many do we have? 30. Okay, I was almost correct. 28, 7, 25, 24, 24. And I suppose we can take this and we can move it off this way so that it is point, what is it going to be? Like 1, 2, 3, 4, 5, 6, 0.7. Oops. Oh, but we're doing... No, this should be spacing. Negative 0.7 in. Delete the millimeter. And it's going to be 2. So we can just go in increments, 6. There we go, it's 6. And so in one step, I've been able to create all of the output pins for this thing. NBandit says... Oh God, it's creating all these parts. There we go. So now we have this massive amount of pins at the bottom of this thing. Luckily, this is going to be locked away as a component. So we don't really have to worry about all this crap in our main design files. That would be ridiculous. So instead, this all gets wrapped into a component that we can then add to stuff. But we need to give it a footprint as well. So I am saving this. And now we have it with my special pin headers. It's nice. It was a riff off your muted comment. Okay, yeah, that's what I suspected. I read the comment at first, and I was like, I don't get what he's saying. And then I'm like, oh, wait, yeah, okay. I get it. Oh, your comment was to minus, I see. What we're also going to do is on these USB headers here. Now, I could actually take this design, and I could say, you know what? I am going to put... We could do that, actually. We could put headers in here, and then I could have those be the USB outputs so that this is no longer breadboard compatible because these are offset from where the breadboard is. But since I am now designing a circuit board for the whole thing, I could actually utilize those pins. What we were going to do is bridge them over to pins 2 and 3. Bridge them over to pins 2 and 3, and then in software, I would tell it, hey, pin 2 and pin 3, you're an input. But we're never gonna figure out what your input is. That comment is very negative. I meant to go to that view. I could put the pins in here. This is what I was talking about with the way Fusion 360 works. I zoomed in, and it assumed that I wanted to see something in the interfield between where the original origin of the camera was and whatever I'm highlighting. See, it's centered itself kind of near where that hoop is. And that is a very natural way to look at things. If I want to look at something all the way over here, I'm going to highlight it with my mouse and drag up. And now all of a sudden, I'm centered on that thing that I've highlighted. It is a very natural way to do the camera. And if I zoom way in, if you zoom way in, your movements are not scaled as much until it actually knows that you want to look at the centered thing and try to scale your movement, scale your scroll speed. So as I move around, I'm highlighting things with the mouse, and it's refocusing what the center point is. It says, oh, you want to go where that mouse is, wherever you left the mouse last. We're just going to orbit around that. That way you don't have to worry about, like, if you're zoomed very closely in, but your camera's all the way out here, then your movement laterally gets very slow because it thinks that you're looking at something super close up and you want to move super close to... It's all... the logic of how the viewport works is... It's a weird thing, but Fusion seems to have gotten it very right. Versus Blender. I'm only comparing it to Blender because I don't know how other programs do it. You actually, okay, you're referencing something you actually saw earlier in the day. So like, I don't know. I don't know if I want to put pins there. Is it possible to put pins there? Do I have like some spare pin headers sitting on the, oh wait, sitting on the desk? That's something that I got. I don't think I have just pin headers sitting here. I think I organized them away. Just like, I don't know. I don't know. I wanted to make a joke there and I lost it. I lost the thread of the joke. I mean, there's a capacitor right next to those pins, but they do look like they're the same size as everything else. It would just mean that this was no longer compatible for plugging into a breadboard, which I kind of think I want to retain. Fine, like, here we go. These right here. Yeah, I guess that is. Here, I'll show you guys in just a sec. Why would they do this like this? I mean, I guess maybe it made routing the traces harder, but for instance, like yeah, that's perfectly compatible, and I could add those pins there, and then this thing would just plug in. Game face. What, huh? How's it going, Madam You? And then I could also, I could add these in there, and I could have those in there, and then we could have all of these I think are Ethernet pins, which I don't need in this project. I don't want to think about Ethernet. I don't want to incorporate that. But if I did put these into the PCB, they are now compatible with the PCB because the PCB can put the holes wherever I want them to be. But then I don't know, man. I don't like that. But if the alternative is, of course, to take D- and D+ and just jumper them over to like 3 and 4, I think it is. Yeah, 3 and 4. And then, of course, this thing has its own 5 volts and all that other stuff that, we can run 5 volts into this in order to power it, or we could just cut off that 5 volts and not have it run out to the plug on the outside so that when I plug in the programmer, it doesn't try to power up my entire 5-volt system. I'm not really sure what I want to do with that USB system. I think I'm not going to include the USB pins. It would be, like, the whole point of being able to unplug this thing is so that it could go into a breadboard and I could work with it over there instead of in the system. So yeah, let's not run those out. Let's not add pins to them. We'll keep them where they are. I just wish they aligned this, because if they made this like a 2-row header, it would be fine to put into, like, well, maybe not into breadboards, but into perf board. It probably has something to do with routing all the traces out of this stuff. Probably complicates it. Complicates it. Okay, so this is done. We're ready to make this into a part. It's going to have to be positioned to the plane as well. Maybe I should do that. No, I'll do that in the actual 3D part. The 3D part's going to be a whole bunch of holes. Much like myself. Okay, so let's close that. And let's go into my parts library. So where do I go for that? I guess we'll go to the schematic. And I'm adding a component, but the component doesn't exist yet. But we're going to go to, I don't have, oh, I do have modules. Look at all these modules. Wait, Teensy 4.1. It doesn't have a 3D model. Oh, how convenient. Wait a minute. It's a Teensy 4.1. I've got all the stuff for it. Footprint, Teensy 4.1. I guess I must have gotten a bunch of models. Hey, that's cool. We can just open that in the library manager. And edit it. And then I can go to the paths. Teensy 4.1. There's a couple of them. Oh, I see. Ethernet and host. And then just the big boy right there. That would be the one you invoke, I guess. And then there's this. And there's a 3D model that don't exist. We can edit that, or I can add a new package. I think I'm gonna, what do I want to do? Yeah, so use a placeholder, I think is what it's doing. Don't use a placeholder. Create a new 3D model. There's my buddy. Is that all just going in the silk screen? That seems like a lot. Well, it's okay. And if it's including all of these pads, I don't want that, because then I have to avoid all of these pads in my design. All these pads that I'm not including. So, I don't know, maybe I want to like change that up as a variation. Let's pull this in as one that has all of the pads, and then I'll make another one without all the pads. Fusion 360 seems nice, being able to see the designed board and components in 3D space. Yeah, it helps you do a lot of that mechanical stuff and thinking about how the meat human is going to interact with the electronics. And also, if you're just extruding solids in order to 3D print, you can see everything in front of you, and then you can do like test prints in order to make sure that things are the way you want them to be. And you can even, like, you could take an STL of your PCB and print it and make sure all the holes are in the right spot. So you'd have like a 3D board with a bunch of components that are stuck in it. It's pretty great stuff. It's pretty nice and advanced. So all right, let's put the main one down on this thing, and we'll just see what that is. So we need to go back into where our model was, and that was 3D part models. And we'll make two variations. One of them will have the truncated design without all of the excess pins. So Teensy 4.1, it looks like it took a picture of it upside down, which, great. Thank you so much, Fusion. I suppose I must have, yeah, I flipped it on the wrong axes. This is recoverable. We can recover from this. It's not dead. It's not dead yet. It just needs a little help. Zoom way in, and then we just get it close. It doesn't need to be totally precise. If you're sweating the precision of a bunch of pins sitting up out of holes, then you're requiring a little too much of this person soldering this thing. So there it is. So I've left a little tiny bit of room in between the headers, and I've left a little bit of room in the actual pinholes. It looks like we're still off by a little bit, though. Okay, so we're back to square one. So what I need to do is I need to take the center position of the holes and the center position of the actual posts, but actually I can use this as an excuse to align things a little bit better. So if I right click and I go move copy and go from point to point, wonderful that everything is selected, and now I have to look in this blue ghost ectoplasm shit in order to figure out where everything is. I can go from this rim right here. So I'm going to select that circle, and then the target point is going to be either of these circles, and now this is all in alignment. To be fair, this thing will be able to fall down just a little bit, but we're not that precise in our height of the, like, we're not putting plastic directly up above it, so. Yeah, that's what, it's unfortunate that conductive 3D ink, 3D printer ink doesn't exist, because I think you could probably print out conductive stuff. Like if you had a dual filament printer, you would have your insulation and your conductor. And if you could figure out what the minimum parameters for that are, you could make some pretty heady prototypes and figure out whether or not your trace layout is good or if you have any mistakes in it, and then get it from a real PCB because you solder that together. If you did like, if you had conductive filament, the problem is when you mix the filaments in the nozzles. So if you had two nozzles, you had a conductive filament, you were able to do all that. Maybe you could undersize the holes so that they squeeze on the pins a little bit, and then you could plug all your stuff in and it would work. That'd be kind of cool. I don't think they can do conductive inks like that without totally shredding a nozzle. Because you're talking about, like, what do they put inside of it? Like copper powder? Well, copper powder is going to shred brass. Maybe not as much. Maybe you could get away with a little bit of it. Okay, so this one is full holes. So I'm going to save this, click OK, click Finish. I need to be able to call this the right thing. What is this extra one? Oh, that one's a placeholder. So if I open up, let's close this for right now. Teensy 4.1, this is the pad layout. I need to basically just make a copy of that pad layout. So if I duplicate Teensy 4.1 and I call it 4.1, oh, abridged. Teensy 4.1 abridged. I'm going to get rid of all the holes that I don't need, just like in real life. And I'm going to get rid of some of the finer elements of the silk screen. This stuff is just excess. I don't need that. I know it's a USB plug. Don't need those. Okay, so here's our abridged teensy, and now the symbol is around it, so we know that a board goes there. It's unambiguous what's supposed to go down there. It just is a little bit redundant if we have all of the holes, because that's going to get in the way of a lot of stuff. Used to reverse engineer IEDs, improvised explosive devices. Yes, I know quite a bit about them. Take the CNC mill method of being able to quick swap tools or heads. They've tried it. Yeah, they've done everything in 3D printing at this point. The technology is no longer super young like it was in the early 2000s, where everything would be like absolute, like a complete mess. Everything was just a nightmare. But now, yeah, the technology is no longer super duper young, and that means that you have printers that do anything under the sun. You have ones that extrude multiple filaments out of the same nozzle. You have multiple nozzles on a printer. You have ones that can drop off an entire print head and pick up like a machining head or another filament color. You name it, they got it, man. So wait, when I copied Teensy 4.1, it made a separate part. No, it made a separate layout, but I need to associate the abridged with... Okay, so if we go back in here and we open up Teensy 4.1 and I add a new local package and I do Teensy 4.1, I can't because it's a different number of pins. Oh, for fuck's sake. Ever use KI CAD? No, although I have a little bit, but I hate this system. That's right, this is a problem that I ran into before, where if you have more pins, it doesn't let you associate the package. If the package has more pins, then you can associate it. So it goes in one direction and not the other. Time to go cuddle some dogs. All right, have fun. What a bunch of piss. So my abridged Teensy 4.1 has fewer pins. That would be these two right here, these two pieces right here, these swap level thingies. If I take those to a different layer, if swap layer is 1 or add is... Okay, so I think I can do something with this. Swap level 1, and then same with this one. Maybe I can do this now? Damn it. Yeah, Fusion AutoCAD bought Eagle, which was the program that I used to use. And so they incorporated it into Fusion 360, which is what this crap is. This crap is entirely convoluted, and it's a little bit batshit insane how it works, but it's how Eagle used to work. And so I kind of know it with the improvements that they've done to the UI and stuff. So this ends up being the CAD program that I like to use, and it has its foibles. Once you learn them, it's a pretty powerful piece of software. For instance, I just pulled in a 3D model of a teensy that was done in AutoCAD, and it had 10,000 components, but I did that in about 4 minutes. And then I oriented it properly, and I made pins on it, even though I was working in the wrong space. I was in the negatives. But still, I was able to put all the pins on it, and then I was able to drag those pins onto pads in 3 dimensions, so that now, if I wanted to drop a fully functional Teensy 4.1 onto my design, I can do that, and then I can look at the 3D model and see how it affects the balance of everything that's going on, like the plastic that I want to surround it, and make sure that the plastic isn't hitting up against anything. The problem that I'm having right now is that I've deleted some of these extras, the ancillary pins that are not necessarily necessary in order to put the Teensy 4.1 down on your design. We have a pretty compact design, and I'm going to have to take every single facet of this thing, like every iota of real estate that I've got on this board, I'm going to have to use. So I need to get rid of these pins. So what I'm trying to do is disassociate these extra pin things. The only problem is reset PGM, ground 3, 3.2, and VBAT. Are these all the pins there? Well, then what about D- and D+? What were those called? So I'm trying to make a variant package that doesn't have all of the stuff. See, they've got 3 different schematics there, host, Ethernet, and Teensy 4.1. But the pins for D- and D+ aren't even defined on this piece. Oh, USB host, I see. UDM and UDP are the ground, 5 volts, UDM and UDP. So those are these 5 pins down here. And then they've got these there. That's for that. And then these are, I guess these are the problem. These ones over here that I removed. Yeah, I did the soldering myself. It's not that hard. We have a pretty nice microscope here. Boop. To take a look at things up close. I'm not soldering the Teensy board together. Hell nah. But, you know, we got the ability to see what we're doing. This is a little dark. Open the aperture. There we go. Open the aperture. Get them out of there. Why is this entered my permanent referential memory? You know, Independence Day was a long time ago, the movie. But for some reason I quoted on the regular. Oops. So the Teensy over here has, what are the pins that it's running? Okay, so it's running certain pins out. Hold on, let's look up the pin out of this thing. Yeah, there's the 3D model. We don't need that anymore because we've got it all up in the system. There you go. Teensy 3.6. We're not a 3.6. What the heck? All the way up here. There you go. Teensy 4.1. So the pins in this area here are on-off program ground 3.3 VBAT. On-off. Program ground, use 3-volt coin cell for date and time power management. Okay. 47, 46, 45. No, that's not what we need to worry about. It's just these right here that we're not using. And this thing, reset program ground 3, 3.3 V2 and VBAT. So that's these pins here. So if we can make these into another part, oh god, we gotta totally reroute this thing. Are you Steve Jobs? Does this look like Steve Jobs, or does this look more like Wozniak? Yeah, like, come on, chat. Come on. Do I look like I'm wearing a fucking turtleneck? Jeez. I've never heard such a fucking comment. All right, anyway. I'm O'Bother. I am me. I am not. I wish I had that much money. I don't have any money. I think I got nothing. Yeah, this is a Sieg X3. A Sieg X3 clone from Grizzly. I got it when more like Wojak. How fucking dare you? I filled in a couple lines to make your comment a little smoother. No, it's a C. Yeah, I got this from the Reddit Millionaire Makers contest. I won the Reddit Millionaire Makers contest. Woo! It means that I got selected in a thread of people saying, yeah, I'll enter. And then a whole lot of people donated $5 to get me up to 1,500. I had almost 1 Bitcoin by the end of the contest, way back in the day. And then I got almost all of it stolen. Somewhere or other, I have 0.1 Bitcoin. I have a sketchbook with all of the recovery numbers on it. When I've seen you first on YouTube, I thought you were the level 1 tech guy. What's that? I don't even know what that is. I don't have a lathe. Everybody always pushed me back when there were a bunch of crazy people here for the pandemic. They pushed me to do a lathe. And I don't have a lathe. Damn it, I don't want to rebuild this entire part, but it looks like I probably have to. It looks like I probably have to rebuild this entire thing, and that would be adding another package to this thing that is these 5 pins, and then I'll be able to create my variation that has the reduced number of pins on it. It's a YouTube channel, mostly AMD and Linux, more directed at servers. Listen, I'm like a European, what is it, Anglo? I'm an Anglo-Saxon, blonde hair, hazel-eyed, bearded, glassed, white guy with a flannel on the internet. I either have a podcast or I have a stream, and I look like everybody else, or a YouTube channel, right? I'm not like an uncommon type of person you see doing this kind of stuff. So it's no surprise to me that people would come in here and say, you look like that other channel. Yeah, I do, because we're like, it's like every podcast. It's so fucking terrible. Anyway, I want the mill, lathe, and shaper. The mill that I have, I am the mold. I didn't think I fit these molds because of the childhood of ridicule that I had in being interested in electronics. But it seems that electronics and comics and all that other bullshit like that is predominantly, maybe not so much anymore. No, and that's actually a wonderful, amazing thing, because we used to get the shit kicked out of us in 1990s high school for being into this sort of thing, and electronic music and all that other stuff. And now nerddom has become more popular, which I universally think is a good thing. And a lot of my peers think that it's some kind of a bad thing that other people would get into your hobby. No, my space is being invaded by people who don't think like me. And it's like, shut the fuck up. Like, you dumb, weak little individual. Like, go away. Like, get out of your own hobby space, because it shouldn't be dominated by sort of this unplastic, this sort of static community. What I love is that the Arduino is specifically, and people go, oh, Arduino, ew, you should be making that timer with a 555. And it's like, shut the fuck, get out of here. Like, nobody wants to do 555 math. 555 is completely obsolete. For $1, you can get like an Arduino style chip, and you could program it to do even more than just do timing. And the point that I'm trying to make is that if you limit yourself, and this goes for like other things like comics and hobbies and stuff like that. Think about the 555. What can you do with the 555? You can do everything with one, right? But the complexity of doing everything with a 555 limits your knowledge to somebody who's deep into the equations and the engineering of the whole thing. Whereas if you teach somebody to do what they were going to do with a 555 with an Arduino, the entire world opens up to them in terms of doing all kinds of really cool cosplay projects and stuff like that. Like, we have lightsabers, chips that you put in your lightsaber, and it goes woof, woof, woof. What am I going to do? Like, that's an accelerometer. Where did that come from? That comes from that institution, the foundation of knowledge that you build with something that's fundamentally more capable, right? 555 is all American phone numbers. That's right. Yeah, indeed. So like, yeah, it's one of those things, man. Like, I don't understand all of the like gatekeeping that goes on, especially in electronics. There used to be a website, and it's probably still around. I just don't fucking pay attention to it because I don't care for it. Called AVR Dudes, where I tried to learn how to program an AVR microcontroller. Like, AVR microcontrollers, they seem pretty accomplished and capable. I would love to be able to do cool stuff, and I wasn't able to figure out anything. you need like a $300 programmer, and then I guess maybe you can get in on the forums and ask a question, and then everybody's going to call you stupid. Whereas with the Arduino, I went, what are Arduino? And I got people's projects and code and everything, and within an hour, I was able to make an accelerometer board so that when I tilted the board, an LED that was facing more upwards would light up. I had 4 little LEDs. I was like, ooh. I'm tilting the board. I'm doing stuff. That was in an hour on like a Sunday at my coffee table when I was first working, and it just flowed from there. I mean, from there you just do stuff with Arduinos. It's great. 555s are Linux permissions. They're about as eclectic as Linux permissions. I'll give you that one. I tried Googling that, but all I got was a calculator. What? Because bother, it's my little area. Well, guess what? It's expanding because it's cool. So, okay. Yeah, the 555 timer. And it is famous and people love them. And I know, listen, I'm a streamer, right? Did you guys see how much chat was moving before I talked about that? Why do you think I say things that I do? Weird. Why is he so passionate about the obsolescence of a 555? Because people love them. People love them. They love them. Flatulent Gonad is printing out a coffee table sized 555. Actually, I think it's a little smaller than that, but still, people love that chip. And I always hated calculating stuff, right? I always hated calculating stuff. You really boil it down, that's it. I hated doing calculations. But then on top of that, to use a 555, you had to do all these calculations. And it's like, why am I doing this? Why am I doing this bullshit? And then you build it and you're like, oh, good, it's completely off because I didn't consider that every single electronics part is a statistical probability that revolves around a, the center of the bell curve. Bitch, I'm the center of the bell curve. You don't even know. Does that mean you're totally average? Wait a minute. Sorry. Okay, anyway, I need to reinvent this part and I need to split off this into its own thing. So I guess what I need to do is I need to copy one of these and call this one T4.1, and we're going to call it, what are those? Reset Program Ground 3.2 and VBAT. Is it like an expansion pit? What do they call it on the sheets here? Oh, bother in the streets, pin out on the sheets. What? What does that even mean? Backside? I don't feel right typing that one in. SD card. It's just SD card, but it's not specifically the SD card because it's this stuff. This is an SD card. What are we calling that? On-off program ground 3.3 and VBAT. Society of High Sciences. I am the bell curve. What? To whom the bell curves. I don't know what to call these pins. Like mid pins. We'll call them mid pins. Mid. T41 mid, and then the pins, we're just gonna have to rename them and then delete them from the other one. So let's get that other diagram. This is where multiple monitors really comes into play. I'm gonna drag this away. You guys won't be able to see it, but it'll be up in my face instead of my video monitor window. So if you guys see anything that you're not supposed to see, I won't know about it. So just tell me if something weird comes up on screen because I won't be able to see like my video monitor window, and there shouldn't be anything coming up, but there's a possibility that, something is activated and I'm unaware of it. But that considered, I mean, everything should be fine. There shouldn't be weird overlays coming on anyway. So let me see what these pins are supposed to be. Where did that go? There it is. So on off. So I'm going to go into the properties and edit the pin names. So on off, oops, I almost spilled my drink. on. Can't, am I caps lock? Oh, I guess that's just on, off. On, off. Program will become PGM. Program, the next one is ground. GND. Egend. Which one is that? On-off program ground. It's 3.3. So 3.3. What was it called in the other part? Oh, I wasn't able to see it. How do I jump from part to part? Oh. Ground 3, 3.32. Ground 3, 3.32. Oh, and then the package isn't associated with it yet. Okay. Ground 3. .32. And then VBAT. VBAT. Delete this. Move this up. Oops, don't delete that. Move that up, and then get rid of Ethernet. Actually, rename it. And I don't have a good name for it, just middle. It's not even the middle. I'll just call it the middle. All right, so I can pull this back in, and dear God, what happened over here? Overlays, and then doot. There we go. Okay, so I have a new footprint associated with this thing. T41 mid. T41 Ethernet is open, USB host, but then Teensy41, I can now get rid of these. Because it's connected to a pad. Oh no, delete. Well, actually, maybe I just need to blow away this whole part and start over. Yeah, I'm gonna delete these. Oh wait, no. I'm going to remove from Teensy 4.1. Remove from Teensy 4.1. And then the 3D part and the pad layout, I'm going to keep, I guess. Let's delete that. Can't. Okay. Weird. There. So I've disassociated all that stuff. Now I need to go into the part individually and go edit Teensy 4.1 like this. Now I think I can get all these. Nope. All these. Nope. All these. Nope. Whatever. Delete. Delete. Okay, let's move that up one. There we go. Okay, so here's the new Teensy 4.1 part without any of the extra stuff. So hit save, click OK. All right, so I haven't done this a lot, so I don't quite know what I'm doing here, but I have two pad layouts for the Teensy 4.1. I have one that I've associated here. Why is that associated with a model? That's odd. Okay, Teensy 4.1 abridged. And then I'm going to edit that one. No, we've already edited that one. Okay, so that one's ready for a 3D model. It doesn't have the 3D model yet. So I can then create new 3D model. And now we have our model that doesn't have any of the excess pins on it. I'll drag and drop for my parts library. Ooh, the program is not happy with the number of things that I have open at the moment. This will have to be moved into my appropriate folder later. But first, Teensy 4.1, bring that over. At a later date, I could potentially add the pins if I decide I want to do a design that has them. But let's rotamerate the reciproboard. Okay, 180 degrees, that gets us into the right orientation. Now we do a point to point, do exactly what we did before. Point here, 2 point. Oh, the camera's in a weird spot. Point there to point there. Bam, boom, bada bingo. Finish. Whew. Editing parts like this is always a nightmare. So that would be our two-dimensional Teensy 4.1 abridged. We have the regular Teensy 4.1, and then now I have a schematic symbol that doesn't have more pins than the other one. And so what I'm going to need to do is associate them both with two different pack. I don't know. I'm going to have to piece this back together and assign all the pins properly. So if I go all the way back to the components over here, now we're looking at assemblies. So this one has one footprint associated with it, and then one 3D model with that footprint, except that it doesn't have any stuff. And I deleted all the different packages that were associated. So let me remove this from Teensy 4.1 because it's a placeholder. Okay, so now we just have Teensy 4.1. I need to add an existing thingamajig to it. Hold on. Where do we get to that? So those are all the new ones. I want to add a component to this. How do I do so? I thought I'd be able to just right-click it and do... Oh yeah, I need to open it up. Okay, now that it's open, I can go up here. This is the confusing... That step right there. Me figuring out that step right there. That little thing right there is really important in making parts, because apparently, if you don't know to do that, right-clicking it and looking for an add existing package thing doesn't exist. You can't put it together like you would a folder tree that you would think that you'd be able to operate like it was a normal computer folder tree, like if you're looking at like a Microsoft product and you're looking at a folder tree and you go, oh, that thing should be in that folder, right-click, add item to that folder. That doesn't exist. You double-click it, open it up, and now you've opened up that package for editing. And that gives you the 3 views screen where you see the 3 different facets of your element. And so in this 3 view screen, I then need to add a package here. Over here, you have a new button that we're going to use later. Add local package or add from web. We're not worried about the package right now. We want the schematic symbol. That's where this button comes in over here. What is going on with this program? Things are this way, things are that way. It's all topsy-turvy. You just got to know. And you saw there, it took me a minute for the screw to turn just enough to hit the neuron where I go, oh, now I know what to do. So we're going to add to the device, and now we can choose what symbols we have in our repertoire. So here is the symbol without the pins at the bottom. And I'll just plop that right in the middle. There it is. Now it should be, I don't know if it's aligned. I guess everything is grid aligned, so it should be okay no matter where you put it. But there's our Teensy 4.1. Now I'm going to add another one. Oops, maybe I click escape and then click it again. So now I add Teensy 4.1 Ethernet, and I'll just put that over here. And then I'm going to add another device. So hit escape, device, add, and then Teensy 4.1 mid. These are the pins that we took out of the middle of the board. And then we're going to add another device. Teensy 4.1 USB host. I'm going to spread those out a little bit. I don't know. So swap level. We're going to put these all to swap level 1 so that they don't necessarily need to be invoked. I think. I'm sort of guessing that this is what we need to do. Next, can, request, or always. I don't know what can means. Let's look up what the swap level or what the add level means. Fusion Eagle add level. Don't you AI, don't you do that, AI. Don't try to answer the question. How does swap level work? I made all swap levels in the schematics to 1 for the components. But when I rotate them in the 2D PCB, air wires don't rotate. What? I just want an explanation. Explanation. Eagle help, add. Function. Add elements into a drawing, add symbols to a device. Add name, package, library, blah, blah, blah. This is a command line. Add command fetches the circuit symbol or package from the active library and places it into the drawing. During the device definition, the add command fetches a symbol into the device. Usually you click the add command and select the package symbol from the menu. If necessary, I might just make this into 2 devices, to be honest, because I don't really know how this stuff specifically works. Does a company make the boards or you design them? The board that I'm working with right now is a Teensy 4.1. It's made by Paul Stoffrigan for the purposes of pretty much just taking over the world. No, Paul Stoffrigan makes the Teensy, which is a legendary microcontroller development platform. There's a bootloader of his own design on this chip, which allows us to plug in with USB and throw Arduino code, throw Python, throw whatever we feel like at this chip, and it runs at a brutal 600 megahertz. So this thing is able to do your homework. This microcontroller development platform boils down all of the intricacies of working with a processor into just simply giving this thing power and hooking up all our doodads to the pins. Then we go into software and we tell it all the stuff we want to do. It seriously truncates the amount of work it takes to work with and select the microcontroller. For reference, the original Arduino, the Atmega 326, works at 8 megahertz. This thing works at 600. We've come a long way. So yeah, what this means is that I could just buy something like this for $35, $40, plop it down on this board, and just connect a bunch of stuff to it. It's the same thing as an Arduino. It's just that Teensy bakes in some features that are really nice, and Paul Stoffrigan seems to be a performance nerd in terms of selecting something that can get very high performance. And so for audio projects and for smart projects and things that do a lot of stuff, for robotics, people like to choose a big, brutal, heavy microcontroller like this. Although I've also seen this thing being used for like making a motor, like a geared motor into a servo. This dude chooses a Teensy 4.0 for all the servos, and then they're all controlled by a Teensy 4.1. And I'm like, bro, your control system is not that complicated. It's just dragging a leg forward. It doesn't need that many computational cycles. But again, the mantra, and it's not something that, like, because that's gatekeeping, what I just did right there. The mantra is that, you know, these microcontroller platforms are available all over the place, and when you're developing something, you don't want to run into performance issues. You don't want to say, well, I guess I need a faster microcontroller. No, you buy the fast microcontroller, you develop and you get it running for that micro, and then if you really want to pinch pennies at that point, you figure out what a lower level microcontroller could run your program. I don't believe in using the eclectic little featurettes of all of your microcontrollers because we've come such a long way. It used to be back in the day, you had an 8-bit microcontroller and you could not do the computational tasks that you wanted to do. And it's like, oh wait, but they've got a feature in the processor that helps me do this. I can attach an interrupt to this pin in a particular way. Whereas nowadays, all of these platforms are so compatible, or they're so powerful that you don't need to get into these little low layer things. You can program for something that's going to work universally across a group of microcontrollers, or even like an entire landscape of microcontrollers, and then it's down to whatever's cheap or whatever, you know, meets your pricing needs and speed. You could just buy that, and then when there's a supply shortage, you'd end up having to completely reprogram all of your software crimes and ornamentation module. Why did you use the low-level features of the Teensy 3.1? Why did you do serial timing in the way you did? I know there's streaming audio output, and it's fairly complicated to get timings to work properly, but if they didn't jump down into the lower-level functionalities of the Teensy 3.1's chip, they wouldn't have had such a hard time moving to the 4.1 or the 4.0. There was a supply shortage, and Paul had to jump to the 4.1 and the 4.0. He had to go to version 4. which is not compatible with version 3 because the microcontroller just became unavailable for a decent price. How's the programming memory on it? I have not fully explored yet, but from our experience of just running stupid little programs in order to run modules, it's way more than enough. I mean, I would be hard-pressed, even if I didn't use the SD card to put graphics on this thing, if I had a full color screen, I'm guessing I could probably load this thing up with full graphics and stuff. I have a couple Arduino Nanos and Unos, but they don't have much programming memory. This thing blows the Arduino Nano and Uno to smithereens. It's only 3-volt compatible though. But like the Teensy 4.0, which is its little brother that uses the same exact processor. Let me get one out. I've got one right here. I've got one right here. Yes, sir. Teensy 4.0. So this is the little brother of the Teensy 4.1. The 0.1 just runs more pins out of the processor. Actually, wait, I don't think that's true. It might be a different processor. I think it's the same family, though. Yeah, different processor. Same company. He's sticking with, who's that again? Oh, I forget. I used to know these guys. We dealt with a lot of their... Is it... It's not Maxim. Who's that? I forget who that is. Anyway, yeah, Teensy 4.4 versus 4.1. Same family of microcontrollers, so it's basically the same stuff. Just one has much more pinout to it and many, many more features, I suppose. But I'm not really even going to be making this thing flex all that much. We're going to be streaming audio out of this thing and measuring inputs. All right, so yeah, I was just looking up how add and invoke work. But I think this is old. I think this is old advice. See, I'm wondering if... Does anybody still use Eagle for PCB design? There's a system in Eagle where I can add these things. I don't know if it'll add the pins to the pads, and I don't know if it'll swap the different versions of these. I don't know how that works. If I have all of those in there, does it... Oh, okay. Add the package variant. Yeah, so depending on the variant, can I have different pinouts? New local package. And this time, yeah, see, that's uncompatible. Okay, so I am just going to ignore these other things for now because I never use them. And now I can add my local package. It's like if the package has more pins, I can add it and it'll allow unassigned pins. But if for some reason the schematic symbol has more pins, I can't tell it to ignore those pins for some reason. So if I add that, then we're done. We've modified our Teensy to not have all those excess pins. In my library, I still got those extra things. So if I guess I wanted to make a different component entirely, I don't think Eagle... And maybe it's just the swap level and the add feature that I need to explore. Because what if I put in something and I take like this? Yeah, it's like I can't do it. Let's check more info. You would think they could have it so that you could invoke the extra pins and then it would plop down those pads. That would be really cool if it could do that. I guess I'll have to make a different one. So now we need to map the pins. Holy shit. Whoa, that's a lot. These are all functionally named, and yet the pin name isn't. Unless 0, 1, 2, 3, 3.3, 3.3, V1 versus 3.3 low. It would have been nice if these would have been labeled properly, because now I can't zoom in on this thing to see what the different pins actually are called. Cancel on that. Zero, zero, zero. Yeah, all right. But then over here, I can't see them. Maybe if I rotate the thing 90 degrees, it would be able to display. But I need to associate those pad names. How annoying. If I double click on this, V in, A ground, 3 low, 23, 22, 21, 20. So I've just got to like take under advisement what these different ones actually mean. This is ridiculous. 32, 31, 30, 27, 26. This one, 31, A 12, 12 meso, 11 mosi. Okay, 9, 8, 7, 6, 5, 4, 3, 2, TX, RX, and ground. Okay, so they are just like that, but ground is there. Ground is like a pin 0. A ground is over there, and then V in. There's like a mid ground on this thing. Yeah, ground 1 is up top, and 3.3 volt, etc. Ground 2 is actually on that sideways header. Oh boy, what a confusing. I think I got this from, did I get this from Staffringen? I think I might have. All right, so now I need to go back and associate the parts. Open this up again. So 0, 0, connect. 1.1 and 1 TX, 1.2 and 2, 1.3 and 3, 3 and 3v3, 3v3 1, 3v3 low, I guess, 4, 5, 6, 7, 8, 9, 10 CS, 11. Okay, so it's just numerically, I think. Sometimes there's curveballs, and you just got to kind of pay attention to what's going on. It's hard because I didn't make both of these, so I don't know what things are called. And it would have helped if the pins on the diagram and the pins on the pads on the 2D layout had the same names under the same convention. Instead, this is G1.24. I guess they kind of do, but 2930, 31A12 should have been 31A2, but maybe it bumps it to a different location. 39. I've had it where the naming conventions are a little bit different, and so it'll bump something down, and so you're sitting here hitting connect on everything, and you're like, oh no, wait a minute, it doesn't line up anymore. You have to like pay attention and skip stuff. Ground 1, ground 2, and then V in. Okay. All right, cool. So we made our part. It doesn't have as many pinouts. We don't have the direct USB pinouts because I want this thing to be able to be pull-outable and put into like a breadboard if I need to. That was a little bit of part surgery, and my parts diagram now doesn't have a full Teensy 4.1. I can make that part separate. I don't know how swap level and add works. So if I mastered swap level and add, I wonder if you could have a dynamic part where if you do the add level and you add extra pins that weren't represented, if it could add pads. I don't think that's how this works. I don't think it's capable of doing that. That would be a good feature, though. That would be a nice little feature. Because then you could have more dynamic things. You could say, oh, well, I need Ethernet. And so you add the thing with the Ethernet on it, and then it adds those pads in. Well, you would think, yeah, that would make sense, but everything that I've seen, I can't seem to get into the Teensy and do that. If I duplicate this, though, so we're going to duplicate Teensy 4.1 and call it full. 4.1 full. We can open that one up. And I got to get rid of this old stuff. Remove that. Then remove this. There's some kind of like a dog party going on outside where I think one of my roommates has pulled all the neighborhood dogs into our backyard or little alleyway, which is a very narrow alleyway, but we have fences on either end. So Teensy 4.1, add that in, boop. Then we add another device that's going to be USB host. Boom. And then we're going to add, I have to hit escape. I'm trying to learn how to do this stuff. The mid pins. And then we're going to add Ethernet. Okay, and that's all the pins now. For some reason, it still has the 3D model. I don't know what's going on with that. I didn't leave the 3D model in the tree. This needs some work. This stuff needs some work. So new local package, and it's going to be this one, which has all the pins on it, all the pads, all the pins. And now we just connect it. 0, 1, 2, 3, 3v3, 3v2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25. How many pins? It was 24 pins, and okay, these have full names on them. Good. What do these have? These have full names on them too. All right, good. So the numbered pins go around the package normally, and all these extra pins have their own designations. 41. Okay, now where is A ground? ET, ET, ER, LN, E, V, bat. Let's just like go down here and look at, oh my God, I have no idea which ones these are. Ground U1 and U2, ground 1. It would be real nice if they highlighted them on the diagrams here, because I don't know which one is which. I didn't name them after all. ET minus, ET minus. ET plus, ET plus. ER minus, ER minus. ER plus, ER plus. ELED, ELED. EGAND. Do we have E ground E? There we go. VBAT. VBAT. Program. Prog. On off. What is UV hist? No. I don't know if on off is represented in this. Which one could it be? Ground 1 and ground 2. I would be guessing if I did that, and I probably shouldn't. There's UD plus and minus, UDM and UDP. So UDM, UD minus, UDP, UD plus. U5 volts. UV HST. Oh, reset would be on off. Unless there's another reset. No, it looks like that's what that is. 3.32 V33 VIN. Oh, VIN is UV5 volts. No, VIN is VIN. This is becoming a guessing game, and whenever that happens, I know I'm going to make the wrong choice. Analog ground was which one? A ground I don't think is pulled out on any separate thing. U ground, U ground. So ground U1 and ground U2. Yep, okay, so connect that. Ground U1, ground U2. The process of elimination is that UV HST, UV host? Or would that be... I mean, it's the last one with the U associated with it, so I'm going to go ahead with it. I'm not going to use this part, so if one day Future Bother is going to add this part because he wants to use all the features of the Teensy 4.1, and then I'm going to put it in the design, I'm going to go, what the hell is wrong with this? This is connected completely wrong. This ground doesn't go here. But it does seem to be matching up. I just can't figure out what analog ground is going to be. If it's going to be, I mean, ground 1 and 2, I guess we've got that. Ground 1. And then, oops, ground 2 to ground 1, disconnect. It's easy enough to run this again and figure out what they are, but it's like, I hate how you have to drop into the program. Like, I would have to zoom in on the pins there in order to see what they're called so that I know that they're associated with one another. It's way easier if I was able to do that. This window supersedes everything else that's going on. And that is something that happens in Eagle. That's a thing that Eagle does. So I think it's maybe something that wasn't refined for... Fusion Eagle. 3.3 V2 V33, or ground and ground 3 as ground, A ground, and ground 3. Ground to ground. I guess V33 is V33 V2, and then A ground is ground 3. To the best of my knowledge, I believe that I've hooked up all of the right pins. Hard to check that over, though, because you need to go into the properties of the pins and figure out, you know, UDP, UDM, et cetera, et cetera. Okay, well, that'll do it for that. And so I'm gonna hit save, and then I'm gonna upload this to my cloud storage that I hate. Create a new version as we move towards version 9092. Boy, that was annoying. I mean, like, I got the Eagle, like, pads, I think from PJRC. I think that's where I got those from. That are somewhere very similar. You know, they're off the official design files. And so everything is, like, laid out for you nicely, and you can just get the part and incorporate it in our design. But the problem is that our design is very much as compact as possible. And so, as such, we cannot use these mid microcontroller pins. I don't want those there at all because I have to be routing traces in a very compact layout. So this is going to be tough. This is going to be a tough one. I don't know if I'm going to need to do 4 layers or if I need to absolutely min-max the capabilities of Fusion. Oh, sorry, of the Seed Studio Fusion PCB service. They call it Fusion 2, don't they? Huh. That has a similar name. What I really love about the Seed Studio stuff is that you just basically send them a file and they create, you know, your parts. Okay, how are we doing today? Yeah, you got some viewers. Okay. That all being said, let's see how comedically enormous the Teensy 4.1 is going to be on this panel here. So in order to do that, what I'm going to do is I can hop all the way back to the schematic. And remember, the progression is schematic, 2-dimensional board, 3-dimensional board. Even if the files are open in a weird order, they should all open when you open them in the design manager. The design manager is there just to have that little tree function. And I really think that Fusion needs to start back at the drawing board and reinvent how you're treating these trees of stuff. Because I think it's a good system. It's a good system having, like, your design has these schematics, and these schematics have PCBs associated with them. I think that's great. The same thing with the parts. The parts have, you know, a tree of functionality. I think they need to kind of rethink how you're adding and subtracting things from that tree. I think they could do a much better UI and a much more competent flow of that whole thing if they sort of retool it to be a little bit more Fusion-esque. I think they could easily have just a really nice, unique product that has little hints of Fusion Eagle still in it, but the flow needs to be smoother, and the weird parts that you run into need to be more smoothly handled. The UI needs to be more intuitive, is what I'm trying to say. I have strong opinions. Okay, let's put our part down. So back into the place components. And now we have our new Teensy 4.1 that is not full. So I double click on that, and there it is. It's all 10,000 pins of this stupid thing. If I place it down, I cause utter chaos. So let's go now to the 2-dimensional board. And remember, we're just doing this to see if all of, oh my God, all this stuff fits. Look at the size of this thing. Oh my God. So I'm going to grab this and center click. And what that does is it puts it on the bottom layer. So now the program knows what it is so that it knows what it isn't. And we basically can only put it in a couple different locations. And that's here, right in the center of the board, because it's so gall darn huge. I don't think I will be able to use, we got to do 2 boards. We definitely have to do 2 boards. It's going to have to be. I mean, look at the size of this fucking thing. Can it go vertically? No way in hell. There's no chance. There's no chance. So I could put it in here like this. And then if we look at the 3-dimensional board, we switch over with the thing and it'll re-render it for us. And since I center clicked on the part, it's going to flop that sucker over to the other side of the board. So just give it a second to reconcile the 10 million polygons that it has to fit this huge development board in with. While physically possible, I do not know how I would fit 6 different assemblies of op amps in here. We have a lot of components that still need to go down. This thing cannot directly output audio. I mean, maybe in like a strange world, I could put some op amps in between these things. Let's get a collection of TLO74s and TLO72s and see how, just continue to run with the idea on the premise that this is comedically undoable, not doable, impossible. There we go. So we're going to chips now. And we hope that there is a loving God. Oh, there we go. Okay, so TLO72. Now, do I need two TLO74s? I think we're doing TLO72, and I don't think I need... Okay, so I only have through-hole and SO because I'm a sane person. Mutable instruments modules, and I don't want to undo all of these connectors, but in these modules, Emily, I should say. I keep adding that because the accent mark keeps confusing me. Emily uses the smaller version of the chips, and there are little clusters of op amps all around the board. And it's a really clever design, and it really smashes a lot in. Actually, we can open up the board layout. We have that. We have the board layout, which actually made building it a lot more fun, having the board layout, because I was able to actually look at the part and click on the properties, and it gave me all the information about the part. But if we do here and we go to modular synthesizer project, this is why when my license goes down to the free version, I'm going to have a hell of a time getting everything running again. I think once I do it, it'll be fine, but so we're going to go to Marbleps and open up this board. See, I didn't do anything with the 3D files. I did use it to translate positions of holes, but I didn't do anything with the Fusion files except for reference where the parts were. Look at that chip, holy crap. This is a very professional design. Hope they made a lot of money off of it. So yeah, the amount of stuff that's just crammed in between all the connectors is insane. And we could potentially achieve this kind of density. Fusion hard mode in 8 days. Yeah, 8 days we got until the hard mode kicks in. It's going to be very frustrating. I'm curious to just let it happen. But yeah, these op amps here are in a different package. They're not the SO whatever. They are much more compact than that. Everything here is fixed values, and they're not on potentiometers. So I kind of want to have potentiometers on this design as well, which is going to make it even more annoying and compact. But like, holy crap, I don't think I can get this far with what I'm doing. The audacity of having open space over here. So yeah, Marbles is an extensive design, and it's got a lot of cool stuff on it, but I don't think we're going to be able to get that dense with our own design. Look at that thing. But let's pull in the chips and see if we can make it make any sense in 2 dimensions. It's insane. Okay, where's my schematic? So we don't need this anymore. So we're going to go to place components, and I'm going to keep it TLO72 because it's done in banks. We have 3 banks of 2, and then we have 3 banks of 2 channels from the microcontroller as well. So we're going to pull in 6 of these. The thing is, like, when I design this, I should design 1 bank with all the appropriate components, and then cut and paste it a couple times. But yeah, we're just seeing if our design fits. MCP 6004, or no, 2, because we only have 2 channels. That's for our inputs. And then I don't have the audio components, but I will be able to make them. It's a simple process. It's basically the thing we showed today, except at the point where I create the 3D part model, all I do is click on the Create in Library IO button, and then I'm brought to a web interface where I put down all the data from the data sheet into a standardized package. So the packages have standardizations to them. There are some variants, there's some weird variables, but they're pretty rare for things like the audio DAC and the audio DAC and the ADC and the, op amps and stuff like that. They are in totally standard packages. They're not trying to mess with you. You can also get them in QFN, which is quad flat, no lead. They have a heat sink in the middle pin, which makes it unhand solderable with a soldering iron. You can use hot air to do that. Or if you're lucky, you can find a QFN package that doesn't have a heat sink in the middle. And that means that you can drag solder the outer edges and it'll solder on pretty well. So you don't have to get a hot air station. Then again, hot air stations are cheap. So whatever. I may use QFN packages in this. That would insmollinate some of this stuff. It depends on what's available. And absolutely out of the question is using a BGA. A ball grid array is an evil, evil thing, and that's what these are. These two are ball grid arrays. That means that you have a very, very dense grid of pins, and that's what all those vias are doing. They're bringing signals in and out of those pins. Dealing with a BGA design-wise is obnoxious, and even more obnoxious is reworking and soldering a BGA. You have to get it aligned just right, and then you have to get those beads to solder down, and then you have to be able to test whether or not they are all connected properly. If you play your cards right, working with BGAs is not impossible. How much is a teensy? A T-E-E-N-C-Y? T-E-E-N-S-Y, teensy. I think this one was about $40. But I think they're a little cheaper than that, but they're not cheap. They're powerful. They're not cheap. They're like an industry leader, and they're easy to use. But yeah, so BGA out of the question. QFN, maybe. I don't want to have to use hot air. The modules that we tested with, we'll have to get the schematics for, are kind of specialty packages. Maybe we'll use actually what I wanted to do was use these packages, because if I order these, like the PCM 5102A, if I order that from DigiKey, I think it's going to be more expensive. I think it's one of those things where if I just pluck this part out of here, I'll be able to use it just fine. I don't know what those two additional chips are. We need to find what the schematic is for this thing. But if I design my thing to have this package, I can literally just heat all this stuff up and just pluck it and place it. All right, so we've got a couple of the chips here. I don't have those DAC and ADC chips. The other one we have are Max 309. Do I have that in here? MPC 23017. What is that one? Wait. Oh, I think that's a port expander. That's a power supply. LM1117. Do I have the variants of that? No, I don't. We're probably going to need an LM1117 in order to make 3.3 volts, but I'm going to need like a big one. That or I power all of the 3 volt stuff off of the Teensy's capabilities. That's a WS2801 LED driver. These are all from previous projects, so. MC14106. Now, none of this, I think none of this is what I'm looking for. 4016, CA3046, no. Oh, the CA3046 is a matched transistor chip. It's very specific. All right, let's just see if this stuff can fit. Switch over to the 2D design. I have to fit all of this. Wait, why is there only 4? 72, TLO72. Oh, these naturally connect power and ground. That's kind of funny. It automatically associates the power and ground with a connection, even though I have nothing. The 0.5 million hertz would be good for brute forcing. You'd have to slow things down so that it wouldn't overwhelm whatever you're brute forcing. Oh, that's going to be tough. I may not be able to do this. Because, like... Oh, yeah, that's right. There's only 3 of them. The question is, though, would I be able to fit an entire circuit in here? And if I drop it down to the lower layer, I'd have a little bit more Well, no, because then I'd be right up against that. I still am anyway. Here, this does not fit. This needs to drop down to the lower level. So center click and it drops down, and then everything inverts. You can also, I mean, a really good thing to do with this is to set your view parameters so that you can see the chips on the bottom of the board like you're looking straight down at them. That's one thing that I do with this often. And it's totally doable within the software. You just have to do a little layer manipulation and it'll do all the stuff you want it to. And I think there's a way to set shortcuts on that. I should really check that out. Yeah, that's tough. This is tough. I'll need these to also, I mean, these actually don't need to be right near the sources. Still not that much room, though. Let's see here. Yeah, those are just for the LEDs, and then I need a whole nother set of TLO74s. So I need to double these up. That's right. Okay. So I've got a whole nother set that's designed for changing the audio down to the voltage levels, up to the voltage levels that we need to output from the modular synthesizer. Because it's like plus minus 10 volts. There's no way that the microcontroller is doing that. It does plus minus 3. So we need to scale it up, 3x in order for it to be viable as a modular synthesizer voltage level. So I need a totally second set of these, and I need to fit them in somewhere. And the bottom layer seems to be the best candidate. But then they need to not go into the microcontroller, they need to go into something else. And then also, yeah, no, this is not going to happen. I may be able to fit all of the op amps on this board and have all of the op amps functioning off of this board. I guess that'll mean that the potentiometers have to also stick out of this board. And if I have a secondary board, then maybe I can do all of the complicated routing there. Because there's all of those buttons need to route to their own pins. All of these ICs need to have resistors on them. And then I also need to consider putting potentiometers on some of them. And then I also need to have 3 DACs and 1 ADC. And where would that go? It's not going to go in between channels. It's not going to go in between these buttons. Oh, and then, okay, we need a connector. Let's put that in. We need a power connector. This is what's going to set us, this is going to tip us over. This is what's going to set it off here. So we need connectors, I think specific. If standoffs on micro, you could put it under. Well, there's buttons under. Here, I'll show you in just a second. What part did I find? We use this in the VCO design, so I'm just looking for a part that I know already exists. FTDI high rows, JST vertical, that's not what we want. Raspberry USB, let's go generic. Connector specific component, chips, schematic, modules. I think I don't have the library on here. Hold on. We need to activate the library, so let's go down to the ones that have my name on them. Connectors generic. Version 5 is there, but then this one is version 13, so I probably want the later version. So I'm going to add the later version in, and we can now look at it in the pull-down menu. Connectors generic. Oh my god, there's so many. Where's the one with the, I need one with the shroud around it. What do we use for our other design? Maybe I'm going to have to open up another one. The ones that connect to the modules themselves are how many pins? 2, 3, oh, they're 10 pin. M25. No, no, no. M10? It might be M5. Yeah, 10 by 2 is 20. We're M5. 5 by 2. And we don't have a 3D model for it. What the heck? Many module designs make use of a front panel layer with posts, jacks, etc., and one with all the ICs. Yeah, that seems to be the direction that we're moving in, is having a like some standoffs that we can put in, and then that'll just locate our back panel on the front panel, and then you plug in the back panel to power. That's sort of the direction that we're moving in. So like this is the right part, but it doesn't have a... Oh, there we go, it does. SHD, the shitted version. So there's our power input. Oh, that's dangerous. That is dangerous. It does fit. I don't know. Well, okay, it overlaps that through-hole pin, so we can't quite put it there. But it does fit right there, and it would be on the bottom of the board, so I have to center click. Yeah, so I could have a power plug like that, and then we can look at the three-dimensional one so that you guys know what's going on. I have a lot of stuff to consider with this. Like, there's enough room for me to put a couple of capacitors for power in here. That's going to be kind of a weird thing, huh? Updating, updating, updating. Come on. There it is. See? It'll fit. That's so dangerous. I don't know, man. Everything's so close. And then these will block stuff. If I do them vertically, though, they have room for their circuit stuff in the middle. Keep going to this one. Let's close this one for now. In order to get this 3D design all the way through, I have to save it, and then I can go to the other side, and I can... Yeah, see, the buttons stick out. I can't totally overlap it. They're not surface mount buttons. I can buy surface mount buttons, but I have a bag full of tactile buttons right here. So I would rather use the buttons that I have, is the through-hole ones. These will stick out of the front by like one millimeter. So they'll be perfect, but... Obviously, I can't really do much with the in-between area of the jacks, but there is a lot of real estate around. This is just a tough layout to consider. Oh yeah, no, I always put the Schottky diodes on the power inputs. Believe me, not gonna make that mistake twice. So, what else? Oh yeah, I was going to reposition them a little bit. So like if I put these there, it moves it away a little bit from the, oh yeah, this one goes here. Move them away just a little bit from that. I see. Can I like fully put this thing up here? I guess so. Do it like that. That still doesn't have much room. These need just one resistor in order to function. So if I put them there, you know, we've got here and here for the resistor to exist. This way. It looks like the dog party's over. That was very distracting and hard for me to continue working with. What all the little ICs do, they have different components inside of them. They have different silicon innards that allow them to perform functions in this circuit. In most of these ICs, what there is what's called well, not a comparator, an operational amplifier, an op-amp. An op-amp is a device that compares the voltage levels of two inputs using math and then outputs something else. They're complicated. They have transfer functions. What we're doing with them is we are taking signals that are sort of low voltage, 3.3 volt signals that are audio, and we're amplifying them up to what voltage flavors the modular synthesizer likes, which is plus minus 10 volts. So we're DC, ground to 3.3, but the rest of the synthesizer talks in plus minus 10 volts. Plus, there's a 20 volt swing. So the op amps can either be rail to rail, or they can be like DC, or they can be, you know, high precision and all that other stuff. There's a lot of considerations there. What we've done basically is take a design from somebody else who makes circuits for the 3.3 volt processors. We've taken elements of those circuits and combined them and done all kinds of other shenanigans with them. We basically tested all this stuff on a prototyping board, and we've been able to get the synthesizer testing module was able to output a voltage level, or sorry, a waveform, read back that waveform and output that on another channel, and we were able to compare the two waveforms, and they were off by like only a couple microseconds. So this thing can interpret input signals and output them very, very nicely. But in order to get all of our channels usable, what I wanted to do is, instead of assigning different channels to different functions, I wanted to have them be universal. And so in order to be able to assign an input or output on any channel that has an op-amp circuit on either end, I decided to isolate things using both a MAX 333, which is a digitally operated switch, and a MAX 3904, I don't know, 3908 or 3904. This is, I believe, 3908. I forget the number, but it's a Maxim product. It's called a MUX. And as you make A1 or A2 or A0 positive or negative, you then close the switch on that channel on 1 through 8. And so I'm able to connect the 2-channel input to any of the 8 outputs. And then I'm able to isolate the output from the input, right? But because I can output and input at the same time, and I have 2 excess channels, I can input the voltage references that these outputs are using in order to boost things, that these inputs are using to boost things down to 3.3 volts. We can actually use those voltage references here in order to calibrate what we see digitally on the inset. Of course, that can't be read by this chip. This chip only works in AC signals. So I also need an analog in DC signal coming out of this amplifier or damplifier right here. So the damplifier takes it from 10 volts down to what our normal range is, and then we can do a sanity check on it using that. We can then take that voltage and tell our output to output a DC level and measure what that DC level is in our inputs. So we can calibrate everything. Whew, I feel like I explained that like 5 times a day. There's a lot of circuit that needs to go down onto this board, and I probably need to do it on my own. And when we're doing the trace stuff, it'll be, was looking at the M2x5 IDC connector, but made the mistake of not checking the pin spacing needed to 2.4, not 1.27. The mistake I made was flipping it 180 degrees. I got my plus and minus 12 volts screwed up. But because I put Schottky diodes in the freaking design, I put Schottky diodes in there, I was able to recover from that mistake. Because again, it's a 0.1 inch spaced square header, so you just solder it in upside down. But yeah, I made the big blunder of making this thing the wrong way around. Gotta love the MUX. The MUX is an extremely important facet of this entire design. But yeah, it was so frustrating getting this in the wrong way. So I'm gonna make sure that I get this right on the new design. But we use a nice 32x16 channel MUX card for test equipment. All relay connections. What? I have a DAC card, like a DAC ADC from 1990 something, but it uses FPGAs. It's like old Xilinx FPGAs and stuff. I don't think it's a MUX thing. A MUX card. That sounds crazy. Does it make all kinds of chattering noises? Anything you do with relays, you want to hear it go because it's awesome. Oh, that's crazy. So you can take any measurement, you can just connect whatever the hell you want to whatever the hell you want with the isolation of a relay. Whoa, muscle cramp. All right, this is going to take a lot of work on my behalf. I do not know if I'm going to be able to fit this all together. If I was like Emily Gillette, and I was working with the smaller sizes, which, by the way, I have. So the temptation is there to use 0402, and well, 0603 is the lower level. Don't do that to me. If I do 0603, I could use those smaller chips. I had a lot of trouble with those smaller chips, but those smaller chips could help me put all this stuff into the design a little better. And maybe we do need to challenge ourselves a little bit on that, because that would open things up a little bit. I need to make the component. I would need to make the component in Fusion while my 9 days boils away. Yeah, yeah, industrial test equipment be like that. The other option for this is, of course, to put standoffs on this board. I can put most of the functionality of this board down like this as standoffs, have another PCB, and then it would be much less compact. And I could have room for my designs to be big and then easily troubleshooted. I could troubleshoot them. There we go. So I've got a bit to think about on this. I mean, in marbles, everything is so huge. That little bit of PCB goes a long way. I feel like I could take, just a little slice of that at that density of design and make it work. I don't know what for like the Teensy, how compact Teensy is in terms of getting all of your components down on the board and getting everything wired. Having that size of trace would be insane. But I would be paying for that. I would have to pay extra for that, I think. I don't know what my minimum board size, my minimum trace sizes are going to be. This is an advanced design, though. This is definitely multiple layers, right? Yeah. Yeah, blind vias means multiple layers. I think we're 4 layers deep on this one. I have a lot to think of. Even though we don't have enough connections. Could use 64 by 16. Have to get tricky with the wiring setup. That is strange. I've never used a MUX card. I don't know what that does. I've used MUX chips, of course, to great effect. My keyboard still works, and we put the Maxim MUXes on that job as well. The MUXes we were going to use for a research piece of equipment, and it's a brain monitoring probe, so you have analog level lines on a 5-volt system because it was that long ago, and so we had to switch this DAC, this 1990s DAC that I just had in my hands, this one, to multiple different outputs of light sensors. And so that's where the Maxim parts came in handy. I was trying to take their through-hole design and turn it into a surface mount one with much more rudimentary software that they had back in the day. And it didn't work out, but I got all the parts in the end. So now I have Maxim MUXes coming up to my neck. Which is why using them in this is great. You can buy different MUXes, though, and they'll be more effective because we are MUXing an analog signal. You have certain parameters that I think by now we probably have better technology for, but we'll be using the ones that I have. They seem adequate for what we're trying to do. Why did the number of users jump up? Did something happen? Do I have egg on my face? What's going on here? What are you guys watching? Nothing's happening here. I got a lot of people. We put DC voltage, analog, PWM measurement, all that to sensors. Each have their own pinout, and we have like 1,000 models. Jeez. Is it for like unit testing before you ship something out? I see. I was never involved with that, but I have heard of it. All right, let's see what the 3D design looks like with these things kind of scooched around. If I'm going to stick with SO8 and not go to a smaller size. I don't know. Does that feel doable? Like, could I get all the components in on that and make the design all right? I don't know. Yeah, like the plus minus 12 is going to run to all those. I need to have a 3.3 volt conversion section around here somewhere. That may be over in this corner. I'll do all the power stuff. I have the upper layer too on this corner. Having ICs all over this thing is going to be insane. And then I'll have this. I'll need a plug for the USB output, unless I keep it like this, and I want to power this thing off of a USB that plugs into the side of it. Actually, I think I want this to spin 180 degrees, and I want SD card access from the side. So that's something to consider. And then each of these making the output voltages that are coming from another chip that I haven't put on here yet, another series of 3 chips. So it'll be this chip and then the chip that's running it nearby. I know, it's like if I don't go with 0402s, I'm up the creek, so to speak. And then I'll also want to have potentiometers on these. So that'll be a big potentiometer, 6 of them sitting out the back of the board. I don't know if this is going to work. It seems like a lot of wasted space if I don't do chips on this board, though. I mean, I guess for the LEDs and for the final, but I would need the potentiometers with these circuits, so. Well, I got a lot of thinking to do about what this design is going to look like. I guess we're going to break. I'm going to get going a little early here because what do we have? We got 3.5 hours. I think that's 4 hours is a good stream, right? Twitch isn't going to come over and like Jimmy tap me and go, you got to stream more. Whoa, I almost dropped my soda again. Oh my God. Yeah, I mean, you can do that. You can do that. I want to keep it adjustable though, because if it moves environments, you know, every now and then you'll want to like calibrate it. I know you're joking, but that's actually something perfectly acceptable. to have like pads and then through holes, and then you don't install one because you tune it. But I'm not going to do that. No. And you know what? Does it need to be adjustable? Does it need to be adjustable? I can take the resistor value from the other circuit and get it close enough. I don't know. I could make that work. I could make that work. Where I get sort of near enough as makes no difference to the value, and then digitally tune everything. So if I'm digitally tuning it, the near enough as makes no difference value just needs to be outside of bounds, barely, to where it can be tuned in either direction that it needs to go. So that's something to consider. That's something actually I should seriously consider, because the fewer big things to adjust. See, what I was going to build was a through-hole circuit that was on perforated prototyping board and had a bunch of big adjustments with screwdrivers. And so it would be this big rudimentary, basically a hammer that we would use to chisel fine rock. But now we're making some kind of a knife tool that would be a little bit more precise. I may leave out the adjustment. Take an hour to find adjust it all. It's not too bad. I mean, it's 6 channels, and you would be running through the channels just trying to hit a voltage level with like your oscilloscope, and then you would, okay, there, boom, now we're at that voltage level, and now the machine will barely need to adjust itself when it calibrates. That's sort of the idea. But if it turns out that all those voltage levels, all those resistances are just about the same, because we did adjust all of these. If these have about the same value resistors in it, maybe I can just leave it up to these values if they're similar. Let's check. I haven't touched my test setup, so. This is the channel looping setup where we had it output a waveform and then measure it and then output it again. So we're using these two. Oh, now that all the dogs have left, my dog is just barking at random stuff. 30K. The audacity. She saw all of her friends, and now she still needs to bark at everybody. $30K. $29.67K. I think we're on to something. I think maybe things are leaning towards 30K. The dirtiest of K, 30K. 29.7. And actually, in the Emily Gillette Designs, I believe it calls for 30K. Let's check. They're 29.7 or something weird like that. Let's open up Marble Eps again, because Marbles is a comprehensive input and output engine. My software hates me for doing this, but it's like, oh, I don't have that much memory and you're streaming at the same time. Come on, Marble Eps. You can do better. Straight to the schematic. And then we're going to the different sheets here. It doesn't help that I've left the software open overnight. 33K. Dun, dun, dun. That's on an input, an MCP 6004. 33K. I thought there was like a 29. Yeah, so this is 33. But we measured 30, so we'll probably use 30 instead. These are the LED circuits that we stole. And that's 680 ohms. And that one uses 100K and 23.7. That would be for the output, and that maybe is what we're measuring. I think we had 33 here. What did we have on the input? Let's check our notes, because we had what's in the notes. $100K, and that's on the input, so this is actually 30K. 30 to 29.6. Ugh. Okay. So I think I can actually get rid of the potentiometers then, because we can adjust that in software. You have a pack of 30 or 29.7K resistors you could swap in to check about on the breakout board. This circuit is fairly deconstructed. It's kind of pretty deconstructed at this point. Like, there's other stuff in here, and it doesn't just all quite get along anymore. So I think I'm going to take this under advisement, and I don't think I need to fine adjust things, because our software will do that at the expense of resolution. If we're scaling our numbers in, we're not going to have as many numbers representing the plus minus 10 volt swing. But I think given the quality of the PCM 5100 and the quality of the TNC 4.1 and the speed of everything, I think we'll still be okay. We don't need to be a BK precision multimeter that can get within 0.00007 digits of the right number. So yeah, I think we're good. What happened? Something didn't scroll. 0 to 3.2 to 10 minus 10 to 10. Yeah, it's the scaling of it is going to cost resolution, but we're using so many awesome things in here that I think will be perfectly fine, especially for my purposes. Well, our goal is to get something working first, and then I'm going to do the short on these two in order to get those two pins to come out on pins 3 and 4. So LR clock and B clock of I2S is not going to be available. For channel 2, we're only using channel 1. We're only using channel 1 of I2S. So for our inputs and our outputs. For some reason, I2S works like that. All right, I'm saving this. I'm saving our design. I've made the note of 30K, so we know that we don't need potentiometers for the output, whatever, these things, op-amp circuit. For the inputs, I believe we're fixed because we're scaling it down from plus minus 10 volts, and we're using very similar values to what is being used in here. We're going to have a 33K resistor and a 100K resistor on it, which is a 1-to-3 ratio. What are these doing? LM324. What are they using for the LM324s? It's 0 to 8 volts, and it's a slightly different circuit. It's a non-inverting. It's also got an LED associated with it. That's a little different from what we were doing. Weird. Okay, anyway, let's close marbles. I am going to, I guess, open this in my other computer and work on it over the weekend and see how far I can get in designing it. I'm still going to try to make this in as small as I can to try to get it to be one board. I think we might be able to do it. Unfortunately, today was a little bit too encouraging for our attempt at getting everything to fit on one board. It was a little bit too encouraging if I kind of reduce what I'm comfortable with in terms of making circuits big and bold. If I smallinate this a little bit more and perhaps use some of the ICs that I bought for the mutable instruments stuff, and I can have the smaller footprint ICs without a bunch of potentiometers sticking out of this thing, we'll still have all the same functionality, and I can make the circuit a little bit more compact. It is going to be a challenge to run some of the connections on this thing, but it's possible that we can do it. And if it's possible, I'm going to make a try at it. And I'm going to get so mad when I put 16 hours of work into this thing and it still doesn't do what I want it to do. Or when we solder it all together and there's like little tiny disconnections like I had with the mutable instruments marbles build. That was particularly annoying because there were like cold solder joints. Going for 2 layers. As of right now, unless I check pricing, let's just check pricing. Let's check pricing. We're about 100 millimeters by 50 millimeters. So if we do Seed Studio Fusion, where's my browser? Where did that go? Seed Studio Fusion. Bonk. Fusion PCB assembly. Oh, I don't want assembly. I want the actual just Seed Studio. Manufacturing. I'm not going to give you my Gerber. Base material, FR4. Let's make it flexible. No. Number of layers, 2 layers, 100 by, let's just give them 50, even though the limits are 100 by 100. PCB quantity, I don't care, 5 or 10. Right now it says it's $4 for 10. 5 would be also $4. What if I go to 4 layers? $50. $50 for 5. Oh, quantity, 44. Yeah, so it jumps up to $50 if I go to 4 layers. 2 layers, $4. 1 layer, $4. The economy of scale. PCB thickness, 1.6. PCB colored. Surface finish. Minimum solder mask. Dam. Copper weight, 1 ounce or 2 ounce. Yeah, keep it 1 ounce. Drill hole minimum, I can keep it at 4.3. Plated half holes or castellated holes, no. Trace width spacing, 6 mil spacing. Go to 4 mil, $71. It's pretty much just everything is tooled towards these parameters. And if I wander outside of it, the price just, because they have to do it in a separate run. They have to like change up their tooling or something. Yeah. Yeah, if we stick to this surface, it's 2 layers, certain spacing. You know, I can throw 2 designs in there as 2 different orders and it'll be $10. It'll still save me money over doing four layers. So I think jumping to 2 PCBs, I'm going to consider as if jumping towards 4 layers because it's way cheaper. You know, that's 10 times more expensive. So, okay. I think that's all I got for today. I need to basically hunker down and do a lot of work. I have a lot of work to do. I've made a lot of work for myself. But it's seeming more and more like it's possible that I can fit this thing onto one board. I'm just going to have to be real tight with my circuits when I put these things together. Drawing the lines is going to be relatively easy. It's just at the scale that I've got with 6 mil spacing. I need to make sure to put those parameters into Fusion so that it knows what I'm doing. And I think the design rule is built into Fusion somewhere, but I'm going to probably do it manually and just make sure that everything like that spacing is going to be, you know, very militantly stuck to. Okay. Hey, thank you for joining me. Mostly Cease Traction at this point. It's mostly one person, but our viewer numbers jumped up significantly. I guess maybe I should consider streaming later in the day, but then I can't spend time with my puppy. It's probably, they probably have different machines. It's probably not like a tooling thing. They're not going to like take down the line and redo it because it's just making money. Like people are sending them designs and they just put it into the software. It puts it all out on the panel and says, this one is a green panel. And they send that to the machine. The machine goes through and it makes a green panel. And then a different machine that's exactly the same as the other machine goes, well, I do panels that have this mil spacing. And so the people who select that mil spacing, there's 10 times less people. Or I do 4 layers and there's 10 times less people, so they charge 10 times more. That's probably one thing like that. I don't know, I'm overly simplifying it, but it's just the way these manufacturers do it. They probably have different lines for different functions, and the speed of the line dictates the pricing of what you're doing. I have to take mine to have the vet in 3 hours for the monthly allergy shots. Oh no! Oh, poor puppy. We have to do eye drops with Willow because she got some crusty eye stuff, and we think it might be allergies, but it seems to be passing. She seems to be better by the day. But I don't want her to have those like stained sleepy seed lines that some dogs do. And so I'm constantly like poking her eyes in order to get the sleepy seeds out of there. And maybe I need to be less aggressive about it. I probably need to let go of my preconceptions. All right. I got a lot of work to do with this. When I get the board in, that means we can turn off our brains and build it. And I can't wait for that. Then I need to actually, wait, why does it say Japan at the top of this? Wait. Oh, that's in Japanese. I see. That turns it over to Japanese. Oh, that's cool. Well, I don't need that. I just need to see the prices. Yeah, so definitely a 2-layer board, which is unfortunate because that makes it a lot. Well, maybe we make it out of a flexi board. $393. Oh my God. Why are flexi boards so expensive? I think there are different services that do it more cheaply. $400. All right, I will catch you guys later. Have a good one. I'll let you guys figure out where you want to go from here because you guys are in control of your own Twitch, right? And did I do the, oh yeah, the end card with all the stuff, all my social media and whatnot. Look at all that. What there is a project with possible flex circuit. There actually are cheaper flex circuit producers. I don't think, or maybe see it as a special deal. There are other people that do it, and I think you could go cheap with that. I would love to explore that at some point, but boy, the prices have to be way lower than that. If we can do like a $20 flex PCB, that would be great. And if 4 layers only bumped the price up to $20, I would be like, all right, let's do 4 layers, but it bumped it up to $40, so I can't really justify the cost. So anyway, I got my work cut out for me. You guys figure out where you want to go. I am no longer going to broadcast. How about that? See you guys on Tuesday or in the Discord.